You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, everybody, and welcome to Common Descent, a podcast about paleontology, evolution, life history, and so on. This is episode 177, and our topic this episode is Neanderthals.
Which is very exciting.
Very exciting. It has human evolution topics, ancient hominins, things in this category come up a lot in the news on the podcast, but it has been a very long time since we've dedicated an episode to ancient hominins or any primates,
Yes.
Period. We will be discussing who Neanderthals are / were, what we know about them, what we understand about their culture, their lifestyles, their relationship to our own lineage, Homo sapiens. It's going to be a whole bunch of fun, and we will be joined by a special guest, Dr. Bridget Alex, paleoanthropologist, Harvard lecturer, and Neanderthal enthusiast, who we had a great time chatting with and learning from. It's great. This is a really exciting and fun topic for us to get to talk about.
Yes, it was so fascinating to get to learn all sorts of stuff about Neanderthals.
Yes, so you will hear that once the main discussion of the episode starts. Hey, one of the reasons why we're doing this episode topic is because, like all of our episode topics, it was requested. We received several requests for either Neanderthals specifically or more hominins and other human species.
More peoples.
From Pedro, Eric, Alexander, Taterboy, Jeremy, Rita, and Lucky Tomato.
Thanks for the requests.
Thanks, everybody. We hope you enjoy. Before we move on, some announcements, starting with our evergreen announcement. We have a Patreon. On the Patreon, we receive support from our wonderful patrons, which allows us to do all the podcast stuff, all of our science education efforts, and in return, our patrons get access to bonus content, they get to do live streams with us, all sorts of fun stuff. One of the rewards that some patrons get is a shout-out here on the podcast right at the top of the episode. This episode, we would like to give a shout-out to Cheryl, Mark, Peter, Dwayne, Petter, and Pontus.
Thanks so much for your patronage.
Thank you all so very much and welcome. Hey, speaking of Patreon, we've got a special Patreon thing going on.
Yeah, we do.
Over the summer, we hit 500 patrons, which is a big old milestone. So to celebrate, we added some new tiers. There is now a Phylum and Kingdom tier with all sorts of very cool new benefits. And we're doing a Patreon giveaway. So if you are a patron, by the end of this year, you will be eligible to win fabulous prizes, which we will announce at the beginning of next year. The top prize there is all the goodies that patrons can get.
Yes.
Which is a lot of fun. Check out our Patreon. There's a link in the episode description if you'd like more information about that. And speaking of ways to support us and interact with us, we have a physical mailbox that every now and then people send us emails and stuff all the time.
Oh,
and it's very lovely.
It's great.
Those are great. We also have a physical mail that sometimes we will get actual physical things. We got a bunch of mail.
Yes, we did. We got lots of cool stuff.
Tons of great mail recently. We got a lovely card and some bookmarks from Elizabeth.
Spooky bookmarks.
Spooky bookmarks. We got a postcard from Yayoi Neko, who we've got. I think this is a follow-up to the previous
Halloween Kitties card.
Halloween Kitties card.
Which is fantastic. I love these. They're adorable.
Fantastic. A whole bunch of great stickers from Eliza.
Yeah.
Some really cool artwork there. We'll post pictures on our social media of all these things so that you can all enjoy them as well.
Some of these will definitely be getting added to my laptop.
And from Danielle, a couple of little ancient reptile figures.
Yeah, we got a phytosaur and a mosasaur.
You listeners, we leave it as an exercise for you to guess which one of us is supposed to get which one of those. Very cool. Thank you all so much for these lovely gifts. We really appreciate it.
It's really cool. It's getting mail is always fun. Like, just getting something in the mail is always a delight. But getting a mail from a listener is just so nice.
Nah.
Thank you so much.
Will gets very excited about receiving gifts.
I do.
Also like it. Will gets really excited about it.
It is one of the things that just makes me happy.
So check out our social media. We'll be posting pictures of the things we've received. so that you can all enjoy it and to inspire you to also send us presents. Because if you want to, you know.
Wouldn't you like a cool picture to be posted?
This is a way to get a bonus shout out on an episode.
Yep.
You send us stuff and you get to hear your name again. No one is obligated to send us stuff.
But we love it. So thank you.
And finally, one more thing that's coming up is the end of the year, which means our end of the year Q&A. Every year we do a big old Q&A where anyone can submit questions for us to answer. We have changed the dates of the submission form a little bit for this year. This year the submission form will be opening on November 10th and closing on December 10th. It'll still be open for a month, but if you were one of those people that likes to wait until the very last minute to get your questions in for the end of the year Q&A, the last minute is past the deadline this year. So it'll be open from the 10th to the 10th. When the submission form opens up, we'll announce it in all the places, and you can send in questions for us to answer on the end of the year Q&A.
And we just answer as many as we can and put out a big old episode.
If you like listening to us talk for 2 hours, you'll love listening to us talk for 4 hours. And that's what the end of the year Q&A tends to be. We've shifted the dates a little bit this year to give ourselves a little extra breathing room as the end of the year and vacations and holidays come up.
Yep.
So if you have a problem with that, don't. So keep your eyes out for that. And I believe that's all the things that we have to say in the announcements.
Sounds good to me.
Which means we can talk about the news. Every episode before we get into our main discussion, we pick some news from recent research and studies and publications in the realms of paleontology, and we share it here and talk about it. Will, news.
I have news about an extremely well-preserved bat skull.
Oh.
Yeah.
That's big news.
That's actually, it's very exciting.
Yeah.
Bat news.
And what a wonderful, topical, Halloween-y creature
yes,
to get to talk about.
It's the right time of year. We used to get bats that would get in our attic at one of the houses I lived in, and regularly, like 2 or 3 years that I can remember, one of them would end up getting stuck down in the house in October. So we would just have a house bat for a little bit in October.
The time.
And we're like, oh, well, it is October, so welcome down, little buddy.
Welcome. Well, listen, when November 1st comes around, you got to get out of here.
Yep.
You got to take your rabies and get out of here.
Overstayed your welcome. Come on. This is research by Suzanne Hand et al. In Current Biology, and the article will be linking to in the blog post, because there's one of those we
every episode
put bunches of pictures, is by Lachlan Gilbert, and is a press release from the University of New South Wales in phys.org. Bats, as many of us are familiar with, are extremely successful and numerous flying mammals and are one of the most diverse mammal groups around today.
True. Episode 59.
But as we mentioned in that episode, their fossil record is very sparse. Mm-hmm. There was one metric they shared in this article that said it is estimated that 80% of the bat fossil record is missing.
That makes sense.
Like, what we have should only be representing 20% just based on how numerous bats are. So, a lot of their early evolution is not well known, especially because even the really nice bat fossils we do have are often flattened, and their skulls are pancaked.
Right.
Which is common. That happens with fossils all the time.
Sure.
But a key bat feature, which is echolocation, is in the skull, and you need that to be nicely preserved for us to see if you have the features for echolocation.
Right.
So one of the most important aspects of many bats today, not all bats echolocate, but a ton of them do, is really hard to study because of the way bat fossils are typically preserved. This is a fossil of a 3D preserved bat skull.
Ooh.
This is an Eocene bat, so it's roughly 50 million years old, or the cave sediment it was found in is dated to that.
So that makes it among the oldest known bat fossils that we have.
Absolutely. The oldest fossils go back to about 57 million years old, so this is right up there.
Cool.
This is a new species, and it was named Violasia saigai, and was found in caves in southwestern France. A near-complete 3D skull, making it one of the oldest bats and the oldest uncrushed bat cranium yet found.
Yeah, because we've talked in like the Messel Pit episode 160, about having a lot of bat fossils, but like a lot of very well-preserved bird fossils in places like the Jehel biota, episode 152. I'm bringing this back.
Yes.
Those are pancake, like
yes.
you were saying.
Smushed between layers.
So they're great fossils, but the skull's not great.
Yeah. That is a great way to preserve things, but it doesn't preserve everything greatly. Like, not all things are equal. This is a tiny bat. as so many bats are, the skull is only 1.8 centimeters long.
Huh.
Itty bitty bat.
So even more impressive that it's preserved in 3D.
Right? So not only is this a key part of the bat that is preserved in a way we don't usually get, but it also is at a time that is going to help bridge the gap between the origins and the earliest bats and when the fossil record gets a bit better toward our modern lineages of bats. So we have a new member that hopefully will bridge the gap and give info between the ancestral bats and the bats we have around today. They analyzed for a phylogenetic analysis to figure out where this bat fits among bats. They looked at 2,665 craniodental characters, so parts of the teeth and skull. Bunch of characteristics. And this placed this new bat outside modern bats and as a sister group to the crown clades. So not within, but next to the bats we have today. Likely not a direct ancestor, but may have been closely related to what would have been the ancestor. It has a unique set of features. It retains archaic dentition, so teeth more similar to ancient bats. And there were some skeletal remains, and skeletal features were typical of Eocene bats, early Eocene bats. So it looks like bats of that time. But now they can look at the inner ear.
Yeah.
And the inner ear does show specializations found in modern echolocating bats.
Ooh.
It has an ear like those of today's echolocating bats.
Yeah. So evidence of potential echolocation all the way back in the Eocene.
Yes. It also has a modern bat-like hyoid bone.
The throat bone.
The throat bone, which are the bones between the voice box and the ear, and in modern bats that echolocate, there is one of these that directly contacts the middle ear bones and appears to be involved somehow in transmitting the high-frequency sounds they will use to make their echolocation. And this bat has some of those features. It looked like at least one of the hyoid bones shared that feature.
All right.
So there's not a way to say for sure it echolocated. But they did say, comparing it to bats today, both ones that do and don't echolocate, it falls right in the middle of echolocating bats in its features.
Right. It fits that range of variation of echolocators.
Yep. It has notably large cavities of the inner ear. The cochlea takes up 25% of the cranial width.
Wow.
And has a large area for hearing, so well-developed ears. They said, once again, we can't say it echolocated, but all of these characteristics fit with laryngeal echolocation that's used by most bats today, and that they described it as indistinguishable. That, like, if you just put it among echolocating bats today, you wouldn't be able to then pick it back out easily.
Right, based on those features.
Yeah, that it fits right in with those. So it has all the toolkit to be able to echolocate. So at least those features for that would have allowed echolocation were present.
Yeah.
Which, if it means it was echolocating, means that bats evolved it well ahead of whales, they pointed out.
Yep.
Which is
they beat them.
a fun note to make, and much earlier than some research had suspected, just based off the fossils we had.
Yeah.
And based off some of some predictions. There are also a bunch of individuals of this species. There were 23 individual specimens.
Oh, wow.
400 bones and teeth were found that made up 23 individuals, indicating that the cave was also likely a roosting spot.
Yeah, there were a bunch of them there.
Which is another bit of evidence that that behavior had evolved by the Eocene. Which syncs up with lower temperatures that would have been happening at this time and may have been the impetus to start roosting in caves. Since it was thought that earlier bats were likely forest dwellers more than cave dwellers. But with the timing, it would make sense that there would be a benefit to move into caves during this time.
This is a very cool discovery. We've talked before, one of the big issues with bats is that they have a very sparse fossil record, and it makes it very difficult for us to learn what was happening in their early evolution, and that so much of even the earliest bats in our fossil record are very much like modern day bats.
Yes.
And we don't have fossils to show us the stages of the features we know of as bats coming to be over those early lineages. This is a really fun study and discovery because, on the one hand, it gives us information about when certain familiar features showed up, and on the other hand, it completely does not help with the problem of fossil bats just looking like bats.
Right?
It's like, yeah, we finally got a really good one to teach us about the evolution of echolocation in bats, and it has the same echolocation structures as modern bats.
Yep.
We need to go back farther than that.
Yeah, and
Which I think that's a very amusing aspect of this to me.
And with this one, there's not. We are running out of room to go back farther with, based on the fossils we found. Like, it is a really bizarre situation.
Yep, that's very exciting. Well, as it happens, I also have some news about ancient mammals, small mammals in quotes. Small mammal. This is about beaver evolution.
Ooh, fun.
So, beavers, which are very large small mammals. This is research by a couple of ETSU people who we know. This is by Kelly Lubbers and Josh Samuels, published in Paleontologia Electronica. In the blog post, we will link to a press release on the Gray Fossil Site and Museum website, which was written officially by the Gray Fossil Site and Museum, and less officially by me.
Yes.
Beavers are a group of rodents that are in a family called Castoridae. The fossil record of beavers goes back to the Eocene, similar with bats. There are, according to this paper, around 30 genera within this family across their various history, and it is around the late Oligocene to early Miocene that the semi-aquatic lineage of beavers shows up. Beavers doing the at least some of the things we associate with beavers, being in and out of the water, stuff like that.
Yeah.
Beavers in North America today are considered one big species, Castor canadensis. That's our modern, iconic, charismatic beavers. This research is focused on comparing that modern species with a fossil species called Castor californicus. Castor californicus has a fossil record that spans around 7 million to 2 million years ago, here in North America. And they're comparing these two species because they are very often compared because they're very similar to each other. They have very similar anatomy. The most common major difference that is cited between them is that Castor californicus, the extinct species of beaver, is a bit bigger than modern beavers. But other than that, they are extremely similar. They are so similar, in fact, that some researchers in the past have suggested that they might not actually be different species.
Yeah.
This study set out to test, all right, how much difference can we actually detect between these two species? Are they distinct species? And if they're super similar, what might that tell us about them? So they did a whole bunch of comparing. They measured 67 skulls and 59 skeletons of both modern and fossil beavers, including specimens from all over North America. They took measurements. They did geometric morphometrics, which is a statistical method of comparing the shapes of things, to get a sense of what is the variation in the shape of these two species and how much overlap is there.
Yeah.
What they were able to identify is that the modern species of beaver is extremely variable over time and space. They did mention, I think, in the paper that in the past, this species has been split into subspecies, in part because of all that variation.
Yeah, yes.
Comparing it with the extinct Castor californicus, they found that it mostly fits within the variation of the modern species. So kind of like what you were saying with the bats, that those ear structures just sort of fall within the range of the modern ones. This falls within the range of the modern ones, including their size.
Yeah.
That this study at least found that statistically speaking, you can't reliably distinguish these two species based on their size, which is the thing that is commonly cited as the thing that separates them.
Yeah, yes. That actually, when you look at the full range of size for the modern species we consider, it does reach the size of Californicus.
Or at least there's a lot of overlap between the two.
Yes.
There were some consistent differences they noticed in like the shapes of some limb bones, but they said this is relatively minor stuff.
Yeah.
So they are actually quite similar to each other. So this led them to two notable conclusions. One is that these two might not be different species. They might be basically the same thing.
That it might be the grizzly Kodiak bear of beaver situation.
Right, or more specifically, it might be a lineage changing slightly over time, because there are changes sort of noted over time. It may be that this is one lineage that has just been, changing slightly perhaps over the last several million years, that what we call Californicus may just be the direct ancestors of the modern species. This is anagenetic change.
Yes.
So as opposed to splitting into wholly distinct different lineages, we may just be seeing this one group of beavers slowly change in minor ways over time.
Well, it's like how we can track that humans have changed in our average, mass and height throughout our time, because a single species can change without actually having to notably split,
right,
and just become a kind of different animal.
Yeah, these
over
are
time
sometimes referred to, and they use this term in the paper, as chronospecies.
Yes.
That is, they're not actually distinguished. There was no separation of them. It's at this time they look like this, and at this time they look like this, but it's the same lineage, most likely from one to the other.
It's beaver 0.5, beaver 2.0,
Right.
beaver 2.35.
Yes. Now, they do point out that this study was not enough for them to confidently say, for sure, these are the same species.
Yes.
They pointed out that there's more things to study. They specified that teeth would be really good, since that's some of the features that identified this extinct species originally. They also pointed out that there are things we could look for in their growth and development, in their ontogeny, episode 33. So this isn't the final, they don't claim to have made the final word on this, but that these may be much more closely related. The other cool conclusion that they draw from this is that the strong similarity between these two species, or two whatever they are, suggests that they were living very similar lifestyles. They were probably eating the same kind of foods, living in the same kind of habitats, doing most of the same things. Their anatomy is basically indistinguishable, according to this study. So, they say we can confidently infer that Castor californicus, the extinct group, was doing all the important things that beavers do today, which would include knocking down trees, damming up rivers, adjusting the flow of water, altering watersheds, which would suggest that beavers have been ecosystem engineers like they are today for about 7 million years at least.
Yeah. This is a very cool study for a couple reasons, because one, it's getting at the difficulty of distinguishing a species. Like, it is touching on the
Where
question
does one
of,
species end and the other begin? Episode 98.
Yes, it's touching on that foundational concept, but it also is a really nice fossil examination of like how hard it is to distinguish a population as being separate enough to be its own thing, or a subspecies, or is it just a regional variant of that species. And so I always enjoy getting to see that tackled with, especially within the fossil record, where there's that added layer of difficulty. Also, cool idea that there's been beavers being beavers, because beavers are awesome.
Yeah.
And it makes sense to me that they've been doing it a while, because that's very complex behavior. So like,
yes,
it makes sense to me that this is a deep rooted thing in beavers.
Well, and it means that we can make inferences about the shapes of ecosystems.
Yeah.
Like, beavers have not only looked like beavers, but acted this way for millions of... This would suggest... So we've got beavers at the Gray Fossil Site. This would suggest that there were at least some beavers at that time doing the beaver thing. They weren't, just living like muskrats or something that don't necessarily do those same kinds of behaviors.
Yes. Because, I had that thought when you were talking about how similar they are, of like, all right, probably swimming, probably eating wood. Those do not require you to build a log cabin.
Right.
Like, that fits nicely in with your anatomy. You should be able to do that, but we don't know that particular very unique aspect of beaver behavior was shared. But if they're that similar, it would...
It's totally plausible. They could have been doing this for a long time.
Cool.
So, very cool. Hey, way to go, Kelly and Josh.
Yeah, good job.
People that I know personally.
Well, I have... So, speaking of things that swim and have big teeth.
All right, well done.
Pliosaurs. This is a study on the origins of macropredatory pliosaurs, which are the plesiosaurs with the big heads and big crocodile mouths taking on big prey. This is looking at the origin of that body type of pliosaur.
All right, cool.
This is research by Sven Sachs et al. In Scientific Reports, and the article is a press release by Uppsala University in Eureka Alert. So pliosaurs are plesiosaurs, which are your four-flippered, long-necked marine reptiles. The pliosaurs are the ones that had shorter necks, bigger heads, still four-flippers, but were more of an orca, great white type predator than the fish specialist that we think that the long-necked, small-headed plesiosaurs were.
Right. Episode 72. Also, pliosaurs include things like Liopleurodon and Pliosaurus.
Chronosaurus and a bunch of those famous big predators. Some of these got massively big, like 10 meters.
Yeah. Predators that we've named after gods.
Yes, exactly. They were extremely successful from the Middle Jurassic to the Upper Cretaceous. And when they show up, there is a notable shifting of who's in charge of the ocean. That they make an impact when they show up. They are dominating members of the marine ecosystem as top predators. But the exact timing of that has not always been clear because of a lack of fossils during that time. And particularly what people have wanted to look at is when they get those defining traits, quote unquote, those pliosaur traits of being a macro predator, taking down big prey with big mouths. The origin for that body type has been estimated to be the early to middle Jurassic, but there are few fossils prior to the late Middle Jurassic, about 165 million years ago. And the more basal and divergent pliosaurs are early Jurassic, but are typified by relatively smaller skulls and more slim gracile dentition, their teeth, with longer necks, so they don't look like the pliosaur body plan that we think of. So the exact transition has been kind of a mystery. This new genus that the study is looking at, this is Lorrainosaurus killini, and was found in the northeastern of France and Switzerland. It was found 40 years ago, and originally was Simulestes killini, but they renamed it as a new genus with this study that is distinct enough, and it dates to the mid-middle Jurassic, 170 million years ago.
So just before the late Middle Jurassic.
Yes, exactly. So just before that point where we kind of are running out of fossils.
Yep.
It is a partial skeleton. The jaws are over 1.3 meters long with large cone-shaped teeth. It has the bulky torpedo-shaped body that is so characteristic of pliosaurs, and was likely about 6 meters in length.
All right.
So
pretty good size.
This is very much a pliosaur.
Yep.
This is very much, it's large. The other ones that they mentioned, the basal ones, were also typically roughly 4 meters.
Right.
So this is bigger than a lot of those other early ones. It's also shaped like the pliosaur, the typical pliosaur body type. It's still small compared to a lot of other pliosaurs it's related to, but it is the oldest large-bodied pliosaur with those macro-predatory features that we have. As they put it, one of the first truly huge pliosaurs. This would have been one of the earliest ones to get scary big. This shows a few things about the timing of pliosaur evolution. It shows that they likely emerged right after the restructuring of the marine predator ecosystems that happened in the early to middle Jurassic around 175 to 171 million years ago. There was a notable decline in many other predatory marine reptiles during that time. And at the end of it, when it finished up, they said it ended by the earliest late Jurassic, 161 million years ago. That this opened things up for the pliosaurs, the top macro-predatory pliosaurs, to come into dominance over things like ichthyosaurs and marine crocodile cousins, as well as other large-bodied plesiosaurs. So this time was an important period, and this syncs up with that being when we see the earliest large-bodied pliosaurs coming in, pinpointing it to likely around 171 million years ago. And it allowed them to look at what the features of these earliest pliosaurs, or at least this one, was like, and how it would have had them fit into the ecosystem at that time. Looking at the dental characteristics of their teeth, they noted that this pliosaur would have occupied a different morphospace, so notably different shape from the large-bodied Romalosaurid plesiosaurs, which were a group of large-bodied, like bulkier, but mid-length necked, mid-sized skulls.
Oh, sure.
So they're not the long, skinny necks, but they're not short and necked and big skulled, kind of in between those.
Mm-hmm.
They were also dominant in the early Jurassic, but they declined in the mid-Jurassic. And they noted that their overlap in time, they would have fit very different morphospaces. They were shaped different, likely doing different things.
Yeah.
And that their decline also likely was important to pliosaurs rising up. So this is just giving a lot of context and timing, letting them kind of pinpoint and narrow down the timing of pliosaur evolution.
Yeah. It's fun because we have all these famous big predator, apex predator type things in the fossil record, but they all had to start somewhere.
Mm-hmm.
And there's tons of research that looks into where did these things come in and how did they come to be what they were, and what were the conditions that benefited that rise to prominence for groups like that.
Well, and it makes me think of in the Toothed Whales episode
172,
we talked about orcas.
Yes.
And that they are specialized mammal hunting whales.
Yes.
And that is a very unique behavior, and lifestyle for whales. And so there's been lots of study into when did that start? Why did that start? Because when they showed up, they became some of the biggest marine predators.
Mm-hmm.
Same here. These were some of the largest marine predators for their time, but also just in Earth's history.
Yes.
How did that get started? What were the things that set up for these dominant, unique, not everyone was doing the big macro predator thing. How did that happen?
Yeah. Very interesting. My last bit of news is about snakes. This is super. I'm just going to read the title of this paper. I love this paper so much. This paper is entitled, "What Bit the Ancient Egyptians?" Niche modeling to identify the snakes described in the Brooklyn Medical Papyrus.
That's awesome.
This is research by Alicia McBride, Isabel Winder, and Wolfgang Wooster in Environmental Archaeology, and we will link to an article in the conversation written by some of those authors. This paper makes me extremely happy. It's so much fun. Later this year, we will do the end of the year Q&A, and we will inevitably be asked, as we are always asked, what was some of our favorite news from the year? And we're going to say, we don't remember any of the news from the year, but the answer is this.
Yes.
This is this one.
Yes. So you include this in your question.
You'll know, yeah. Put this in the question to remind me that we talked about this. The Brooklyn Papyrus is a medical text from ancient Egypt. They're written by people in ancient Egypt, and it focuses on snake bites.
That's awesome.
It is a medical treatise about snake bites, their effects, and their treatments from ancient Egypt. It has been dated to between about 600 to 300 BC, but the authors noted that it is probably copied from a much older text.
Oh yeah, that makes sense.
It probably goes back further than that.
This is not a first edition.
Yes. The Brooklyn Papyrus describes 37 different snake species, and, as you might expect, herpetologists today have attempted to identify what these snakes would have been based on the descriptions in this text. This is difficult. For one thing, these are not modern academic descriptions of snakes, so they can be imprecise or they could be focused on features that we don't focus on today. But also that some of the identifications that herpetologists have found most fitting are snakes that don't live in that place.
Yeah.
The place where ancient Egypt was is not exactly the same as modern Egypt, but the region that was ancient Egypt, some of the snakes that are identified there don't live there. For example, there are a couple of examples given in the article and the paper. One snake, described as, quote, patterned like a quail and hisses like a goldsmith's bellows, has been identified as most likely being puff adder.
That makes sense.
Similarly, there's another snake described as being a four-fanged serpent whose bite causes rapid death. The description of this one seems to fit the boomslang.
Cool.
Both of those snakes live much farther south than the region of ancient Egypt where people were writing and using this text. So this study aims to determine basically, are these reasonable identifications? Could those snakes have once lived in that region?
Yes.
Could it be that they used to live up there? To determine this, they did what's called niche modeling. So you build models that take into account the environmental conditions across the range of these species, and then using what we know about ancient environmental conditions, can you make estimates about where would have been suitable habitat for them?
Could they, would they have even been able to survive
Yes.
in that area at that time?
They chose 10 of the species that have been identified by herpetologists as matching the descriptions in the Brooklyn Papyrus. They specifically chose 10 that don't live in that area today, but which it seems like maybe they could have. The 10 species, by the way, because this is my kind of paper, so I looked it up. The 10 species are black mamba, puff adder, boomslang, black-necked spitting cobra, Levant viper, Moorish viper, Palestine viper, black whipsnake, and the rhombic night adder, and then another close cousin of the night adder. So a bunch of cool venomous snakes from Africa.
Yeah, good list.
Africa and the Middle East, I should say. They tested the models on modern snakes, and the models that they built did a very good job predicting modern distribution of snakes. So then they ran it with what we know from environmental conditions from about 4,000 years ago.
Cool.
Which is early in the period of ancient Egypt. At that time, conditions were more humid, habitats were distributed differently. Their modeling found that 9 of those 10 species are predicted to have at least been able to live within the borders, as it were, of ancient Egypt.
Yeah, that it would have been habitable for them during that time.
Yes, some in different parts of it, some along the coast over here, some over here.
Oh, that's cool.
But not all necessarily in the exact same place.
Yeah.
But that 9 of them, there should have been habitat there that they could have lived in.
Yes. That people should have been able to bump into them if they were living there.
Yes. The 10th one was the rhombic night adder, Causus rhombiatus, was not modeled to have been able to live in that region, but they noted that their model did have it plausibly living in some nearby regions that are well-documented trade partners for ancient Egypt.
Yes!
So people who were ancient Egyptian, people who lived in that region, who may have benefited from this medical text, could have been visiting places where they may have encountered this snake.
Very cool.
So, the authors say this is, if I remember right, the penultimate sentence of the abstract. It is one of my favorite sentences I've ever read in an abstract. They say, "We therefore conclude that all 10 species modeled in this study could have bitten ancient Egyptian people." They point out that this is a really cool demonstration of combining information in ancient texts with modern technology. And they said there was a cool line that I think was in the article, that even a fanciful or imprecise ancient description can be informative.
Yes.
We can still use that to help us infer things about the past.
That is very cool. It's always neat. I like learning about historians and archaeologists who are trying to interpret what is being described by ancient peoples, especially when it's animals, because obviously that's what I'm going to be interested in.
Yep.
But that's always fun, and it's always a neat note when they use a description that would have made complete sense to them. That is an analogy or a reference that they're like, yeah, everyone knows what that sounds like.
Everyone knows what a goldsmith's bellows sounds like.
All right? Who hasn't heard that at some point? I've seen the comparison made to how all of our recipes say egg, but not whose egg?
Not what animal the egg should come from.
Egg. Any egg-laying animal's egg. So that's fascinating to have to parse that out and try to reinterpret it and decipher it. But then the overlap with modern technology and our modern way of interpreting species.
These evidences are corroborating.
Yes.
So in studying how habitats and climate conditions and animal distributions have changed over time, we're not relying solely on this ancient medical treatise, but the descriptions in that treatise line up with our climate modeling technology, which is really cool.
Well, and it makes me wonder, and I have no clue, but it makes me wonder if other people studying other Egyptian texts might have a moment of okay, cool, because that one description was we were arguing about exactly what they meant by that. And if you actually did confirm it's referring to that leans us toward this. Would that help with any other
Right.
when we are able to overlap it that way.
Well, and according to what they said, there are 27 other species in there and it sounds like not all of them are quite as confidently ID'd, and some of them it sounded like, if I read it correctly, are lost.
Yeah.
So like they were, I don't know what the story is there. But yeah, this is a really cool demonstration of combining information from these different directions.
That's a pretty good favorite news.
That's such a cool, and it's about snakes.
Yep.
It's got everything. I'm very excited about this news.
Nice.
Link to that article in the blog post that will be posted after this episode releases. And since we're on the topic of right, we're in archaeological.
We talked about people.
Anthropology. Now we're talking about humans.
Yeah.
And stuff. What a great segue to move into the main discussion. After this short musical interlude, we will be joined by our guest, Dr. Bridget Alex, to talk about everyone's favorite, very close cousins of Homo sapiens who have been studied for many decades that are called Neanderthals.
Neanderthals!
Stay tuned. Hello, Bridget.
Hello.
Thank you so much for being here with us to talk about Neanderthals. We're very excited.
Yes, it's one of my favorite topics, and I'd probably be talking about them if you didn't invite me with whoever I was with.
That is a mentality we like to go into the podcast with. This is a conversation we would be having anyway. We're just happening to hit the record button so other people can hear it.
Mm-hmm.
Before we get into it, would you please introduce yourself for our listeners?
Hi, listeners. I'm Dr. Bridget Alex. I have a PhD in human evolution and archaeology, and my research has focused on the extinction of Neanderthals, the spread of Homo sapiens, and the question of where and when these different humans met. And so I've worked on many excavations. I've worked in laboratories where we like to crush up some bones and artifacts in order to measure chemical properties of them, to answer things like how old they are or what kind of things they ate. And I also am an editor for a magazine called Sapiens, where we share anthropology with the public. And I teach about science communication and archaeology at Harvard University.
Fantastic. We encourage our listeners to check out Sapiens. That's actually how we got in touch with you, was through Sapiens. Now, as the title of the episode implies, we are here today to talk about Neanderthals. Now, before we actually start getting into the question of who Neanderthals are, I want to take just a moment and talk about the pronunciation of the word Neanderthal. As longtime listeners of the podcast may have noticed, Will and I say the word differently.
Yep.
And different people say the word differently. Could you just very briefly give us sort of answer this question of what's the deal with the pronunciation?
Sure. And you might think that I care a lot, but I actually don't. And I switch back and forth whether I say Neanderthal or Neanderthal, just kind of based on my mood or who I'm speaking with, or, how the wind is blowing. So I don't really have strong feelings about this, but I can tell you the source of the confusion. So Neanderthals were the first extinct type of human or human ancestor or relative that was given a scientific name. And this happened in 1864, so pretty early days for thinking about human evolution, soon after Darwin published On the Origin of Species, and scholars are grappling with the idea that there were extinct humans that no longer exist. So this article calls them Homo neanderthalensis. That's the formal scientific name that exists to this day. It's spelled with a TH in it. So if you're an English speaker, you would read that Neanderthal. If you were just shortening it to the kind of colloquial name Neanderthal instead of the full scientific name. And if you're a German speaker in that area of Germany at the time, you would say Neanderthal, because the TH was pronounced tall, not th, like an English speaker might say. And then also it got even more complicated because later in time, Germany standardized spelling and changed the way TAL, which means valley, by the way, or TAHL, which also means meant valley. They changed the way valley was spelled. So now it's always spelled Tal, but you don't change the way the scientific name is spelled. So the spelling remains the same as it's been since 1856. When you look at the word, if you're an English speaker, you might think to say thal, because that's how we pronounce th. If you're a German speaker, you would say tall. And therefore, either when you're saying the colloquial name Neanderthal, either is correct. But if you're spelling out the formal scientific name, you should definitely use a th. So that's the only thing I ask of you when you're spelling out the genus and species name, to spell it with a th. Otherwise, I don't care how you write or say just the word Neanderthal.
Great. That us too.
Yep.
That is our. You heard it here, dear listeners. None of us will judge you for how you say the word Neanderthal.
I definitely know. I've switched back and forth.
Mm-hmm.
It'll often depend on whether I'm reading it in notes. Like if it comes up in news, I'll end up saying Neanderthal because I'm spelling it out. I'm sounding it out as I'm reading it.
Mm-hmm.
But then if we're talking about it, I'll often just mimic the way you last said it. Right. So I'll say Neanderthal. And it'll be those moments where I'm having a conversation and I'm going back and forth between those, and my brain goes, I don't actually know which one to use right now. So it just, whichever one comes up.
So both will probably show up in this episode.
Yes, I also tend to say what the people around me are saying, just to make everyone comfortable.
Mm-hmm.
You know, sometimes in English speaking circles, you come off as a little pretentious if you say Neanderthal. It's Neanderthal. So it seems more comfortable when I'm based in the US to say Neanderthal, but often if I'm based elsewhere in the world, Neanderthal is what people are saying.
Well, here on the podcast, you can choose your favorite.
I remember the first time someone, said it as Neanderthal in the conversation, and I had that moment of, is this a correction or am I mishearing? Like, are you saying th, but with a very hard t, and like, am I mishearing you? And I was very confused by the whole conversation of like, are you trying to correct me or am I mishearing you? Should I, if I match what I think you're saying, am I making fun of you?
Right. So with that out of the way and everybody on the same page, kind of, let's talk about our main topic themselves. In brief, if you would, to start us off, what, or perhaps more appropriately, who are Neanderthals?
Yeah, well, they are humans, just like Homo sapiens are humans. They're another lineage or species of human, formerly called Homo neanderthalensis. And as I mentioned before, they are the now extinct type of human that we've known about for the longest, that we know the most about over the years. Starting in the mid-1800s, researchers have discovered fossils from well over 300 Neanderthal individuals, many, many bones constituting well over 300 individuals. They've found probably millions of their stone tools. And unfortunately, there are no Neanderthals around today. But this lineage of humans had a pretty good run on Earth. They seem to have existed from about 200,000, 250,000 years ago until 40,000 years ago. They spread pretty far and wide. Fossils from Neanderthals have been found all the way from Iberia to Siberia and down into Southwest Asia in countries such as today are called Uzbekistan, Russia, Georgia and Armenia, Iran, Iraq, Lebanon, Israel, and most countries of Europe. So, they're a pretty successful group of humans. They did go extinct at 40,000 years ago, which is what do they call it? $40,000 question. What happened to them? So I'm sure we'll return to that. But they're generally thought of as kind of ice age humans, and they did absolutely live through some absolutely frigid times when there were ice sheets over northern Asia. And, I certainly would die within a few days if I tried to live in those conditions with my current skills. But they endured and survived, but they also lived through different climate phases where Europe was as pleasant as it is today, if not a little bit warmer. And they hung out on beaches, and they probably swam in the Mediterranean and enjoyed the French Riviera, just like humans do today. So that's a high level view of who the Neanderthals were. And I should mention that I'm sort of a Neanderthal advocate, defender, proponent. I think they were quite intelligent. And if you would bring a Neanderthal in a time machine and raise them with our current technology and knowledge, I feel like, they could do anything you could do if you just gave them a chance,
Yes.
It'll be interesting. And of course, we'll be going into all sorts of detail over the course of this episode. But what a fun thing that we get to do as scientists, as humans, to investigate the lives, the comings, the goings, the culture of a different species of human.
Mm-hmm.
It is just a very fascinating thing to wrap our heads around.
Yeah, well, and it's I like that emphasizing that up front, and that that's starting with that, because that's, I think, the disconnect that so many people get stuck on, because human nowadays means Homo sapiens.
Right. There's only one.
Yeah, we're the only one. But when you have to introduce, it's like, no, before human wouldn't have just meant us. There were multiple options for what that could have been referring to, what that term could have meant, and that's a very alien idea nowadays for a lot of people.
Mm-hmm.
And so it's a critical thing, I think, when it comes to actually considering Neanderthals.
Yeah, it's really a boring time in human evolution, I would say.
Right.
Since we last shared ancestors with chimpanzees over 6 million years ago, and we, our ancestors broke off onto this different evolutionary path of walking on two legs. There are always numerous species we call them hominins, so any species on the branch that eventually leads to humans after we split from chimpanzees are called hominins. So there were always, sometimes a dozen varieties of hominins living in different regions, and sometimes the same regions. And then at the time of Neanderthals, when they existed, if you were to go back in time, say 100,000 years ago, there are at least 4 types of humans around, certainly probably more. And with new technologies like ancient DNA, we're discovering more. So even, at the time of Neanderthals, it wasn't just Homo sapiens and Neanderthals. There's another sister species of Neanderthals called the Denisovans. There's another group called Homo floresiensis, or the hobbits, who are these short, 4-foot tall humans who have only been found on one island in Southeast Asia, the island of Flores. So, Neanderthals are like the least of your concerns if you're thinking about the other types of humans. There's ones we hardly know anything about, but Neanderthals, we actually know more about them from this time period, from the Stone Age or Paleolithic, than we do our own ancestors for a good chunk of time, because for much of this time, Homo sapiens are in Africa, where things like ancient DNA does not preserve very well for if you're going this far back. But in Europe, in caves that are basically refrigerators, it has preserved quite well. So in terms of ancient DNA, we have a much richer record from Neanderthals. And even fossils, because there have been over the years so many excavations in Europe, it's a relatively small continent compared to Africa. You can kind of check every cave, and there's a lot of archaeologists there since the origins of the discipline as a scientific field. So, we just are swimming in evidence of Neanderthals from this time period that we don't have the same amount for Homo sapiens.
Oh, I did not know that. That's really interesting.
It is very cool. Well, let's go into some of that. Talking about, now, like you just said, there were many different humans. There were a variety of different humans that shared the world with our ancestors and with Neanderthals. This episode is not about them. So they will get the short mention in this episode. But talking about this comparison between Homo sapiens, our species, and Neanderthals, what are some of the things that characterize Neanderthals? What are some of the features, both physical and behavioral, because we're talking about ancient humans, that distinguish Neanderthals from others?
Yeah, so if you were to see a Neanderthal walking around, I think you would be able to tell that it's more different looking from any human you've ever seen before than any living human or Homo sapiens of the past. And someone who's a specialist, someone who's an anthropologist or paleoanthropologist, looking at their skeleton can say, this is a Neanderthal, this is a Homo sapiens, and they can do that for many with even just fragments with many parts of the body. Some parts you can't really tell, but much of the skeleton, fossilized skeleton, you could say whether it was a Neanderthal or Homo sapiens. And those major differences are that Neanderthals are shorter and stockier. They look more like a wrestler compared to Homo sapiens, who look more like marathon runners. Our ancestors were taller, more gracile or slender. Neanderthals are short, and we use the term robust, meaning like much about them is very thick. And of course, we don't have any soft tissue surviving, so we can't really, we don't have any surviving muscles, for instance, but we have bones that show the attachment sites for muscles. And based on how big those attachment sites are and how much they sort of got worn down over the course of a lifetime, we can tell that, yes, they seem to have very big muscles as well.
Yeah, not just thick bones, but also would have been pretty muscular.
Heavily built people.
Yes, heavily built people. And when we try to estimate things with skeletons, you can get a decent estimate of height because, much of that is based on your skeleton plus a little soft tissue that gives you, I don't know, maybe a few more centimeters. But, most of the ones that from their skeletons look like they might have been biological males are about 5'5" on average. Females about 5'1". So, certainly there are living humans that tall, but they would have been thicker. So like a 5'5" male might have been about 170 pounds. A 5-foot female might have been about 145 pounds. And these are kind of estimates we make with regression lines and looking at different things like muscle attachment sites and trying to estimate how much bulk Neanderthals had.
Yeah, very interesting.
So that's the, overall physique. And many researchers, myself included, believe that their overall physique is cold adapted. So that, through evolution, they were, through much of their evolutionary history, living in ice age conditions in Eurasia. And, the individuals who had, more volume to surface area could retain heat better. And even if you look at living peoples today, populations around the globe, those who live and traditionally have lived in cold regions tend to be shorter, with more volume to surface area. And those who are living in much hotter regions tend to be taller and slender. So, and we see that in other species as well, or variants of a species that live along different temperature climes. And so this is kind of a well-observed rules in biology, and Neanderthals seem to fit it, that they have this kind of cold adapted, short, robust body plan.
Yeah. I remember reading some study not too long ago that was talking about their nasal cavities being adapted in ways that seem to also fit that mentality of them operating in colder or drier climates.
Yes. So different parts of the body also seem to, like more smaller things like the nasal cavities, to warm up the air more before it comes in. They have bigger noses. Your nose is cartilage, so it doesn't preserve, but you can figure out how big a nose was based on the missing space in the skull. So yes,
footprint, so to speak.
Yeah, the nose print. Yeah. And then in terms of their skulls, that's another thing, that their skulls do look different from ours. You would, if you were to, have a skull of a Homo sapiens on one hand. Oh, I should have brought some. I usually have casts on hand, but
we'll put pictures in our blog post after the episode.
Yes.
So
okay. So broadly, the Neanderthal skull is more shaped like a football, or an American football. And the Homo sapiens skull is more like a soccer ball, globular shaped. And Neanderthal is more kind of oval, long and oval shaped. But in terms of overall volume, like how much brain could you fit in that skull, they're definitely overlapping. And, there's lots of measurements of Neanderthal skulls, just like living humans. Not every Neanderthal had the same size skull, but their range is the same of the ones we have measured as Homo sapiens from the same time period, from the Paleolithic or Stone Age. So they range from about 1,100 milliliters, if you wanted to fill it with liquid.
Sure. Have your Neanderthal skull mug.
Yeah.
Puree brain.
from about 1100 to 1700. And that's kind of the range. So on average, they're Stone Age Homo sapiens and Neanderthals are about 1400 cubic centimeters or milliliters.
That is really interesting for it to be a different shape of brain case, but still about the same amount of brain case. That's interesting. I don't know. That just seems like a unique shift. I wonder if what benefits that different shape might have had.
Yeah, were their brains rearranged in some way?
Yeah, or was the skull shape on the outside important for that?
Yeah, and when you look at earlier species of Homo or hominins, so earlier ancestors such as Homo erectus or whatever ancestor was immediately before Neanderthals and Homo sapiens parted ways, they tend to have kind of more elongated skulls, like low, longer. And so what is unique about Homo sapiens is we evolved these globular skulls. And so that's kind of a new trait on the branch that leads to Homo sapiens, more globular soccer ball shaped skulls. And Neanderthals seem to kind of retain the more ancestral state in their skull shape, as well as some other ancestral features like big brow ridges. So they probably had like these protruding eyebrows that might be the easiest way to say, hey, that was a Neanderthal. And they're not part of our species.
Right. They also don't have a chin like we do, which is
that's right.
Chin is a very Homo sapiens feature.
Yeah, I mean, people are going to debate this. What is the purpose of the chin? But Homo sapiens are the only humans or hominins that evolve a chin. It's handy if you're, an anthropologist and you're looking at a skull and you're trying to say, what species is it? Oh, does it have a chin? This little bony knob at the end of your lower jaw. It is unique to Homo sapiens. They evolve it, but the others don't. But people debate whether it has any function or it's just kind of, I'm sure you think about these kind of things a lot, just something that evolved to make room for something else, kind of a architectural byproduct of the face of the skull, or was it sexual selection, like, oh, individuals with a prominent chin are sexier, I'd rather mate with them.
A nice strong chin.
Yeah, I don't have an answer to that, but people certainly spend a lot of time debating it.
Yeah.
Well, it made us more photogenic for movies and movie stars. Like we needed that prominent
Neanderthals couldn't do Hollywood. That wouldn't have. Well, speaking of Hollywood and photogenics and stuff, we will for sure go into some more detail in a bit about what we know about Neanderthal culture and lifestyles. But are there things that stand out on the surface level of behavioral differences that distinguish Neanderthals from our own species?
Yeah, if you're an archaeologist and you're, digging at a site, depending on the region, but let's say you're digging in Europe, or how about France? A lot of excavations happen there. Based on the stone tools that you find, you could probably accurately guess whether Neanderthals lived there or Homo sapiens lived there. If the site is, kind of at the border, let's say it's like 45,000 years old, maybe it could be Homo sapiens, maybe it could be Neanderthals. You find some stone tools, you could guess who it was. So Neanderthals typically, at least in Europe and for much of their time on Earth, they make a style of stone tool that archaeologists call Middle Paleolithic or Middle Stone Age sometimes. And basically, they took a big hunk of rock, some sort of volcanic rock like a flint or obsidian that breaks easily into nice crisp pieces, and they hit it with another rock and they would keep knocking off pieces, but it's not a brutish technology. It's incredibly sophisticated, and if you try to make stone tools as exquisite as the ones Neanderthals made, you would definitely fail without maybe like years of training, to be honest. And some archaeologists do this. They do train for years learning how to make stone tools as different types of humans did in the past. But basically they would like knock this stone tool, knocking off pieces. And it's those pieces that they would then shape into something like a knife or a scraper or a point that they could fix onto a wooden spear and things like that. So they keep knocking things off, but it's very deliberate. And oftentimes they're knocking off these kind of broad, thin, triangular points that would be good for putting on the end of a spear. But they're a little bit hefty. And so many researchers think they were good at arming thrusting spears, so things that would be handheld, as well as other handheld tools. But they're not so kind of light and aerodynamic that you could use them as bow and arrows or throwing spears or other types of projectile weapons. And Homo sapiens do make skinny stone tools that were probably quite aerodynamic and could arguably be put on throwing spears or bows and arrows or projectile weapons. So that seems to be like a pretty stark difference in the artifacts that they left behind if you're just looking at stone tools. And the vast majority of artifacts we have from this time period, millions and millions of them, are stone tools because, of course, stone survives forever. Whereas other things Neanderthals might have made, whether it be bedding, items crafted out of wood, have not survived.
Yeah. So often we talk, and when we talk about the fossil record, we discuss all of the biases and the challenges of bones and shells and stuff getting preserved. So having a group of species that makes characteristic things out of rocks is great.
Thank you.
That is so convenient for us because those preserve phenomenally well in the geologic record. That's what the geologic record is made of.
Yes.
But then now you have this tricky thing where we now know some living primates that make stone tools.
Yeah.
Chimpanzees and various few species of monkey. So it was always assumed when we found stone tools from the past that certainly a hominin made them, and probably a species of Homo, so something in our own genus. But now it's like, oh, monkeys in Brazil are making things that are stone tools, according to our definition of them, cracking rocks together and getting handy items from them. So
modifying it to be what they need.
Yeah. Well, nothing's allowed to be too easy,
right?
Yeah.
In science, we keep trying to make these boxes, and nature keeps refuting the notion of a box.
But I really appreciate you making the point, because like I'm one of those people that like watches blacksmithing videos on YouTube, even though I don't do any. And I've watched the flint napping video and them showing like, here's how you start it, and then we move down to a smaller rock, and then you get like an antler to like shape bits, and like it is incredibly precise. And so I don't know. To me, that is puts Neanderthals into a context of like they were doing something that's like artisan skills.
Right. It's not as easy as just knocking a rock against another rock and hoping.
This is a true artistic skill like that. I would, like you said, take years to master it.
Yes, they certainly understood the physical properties of rocks, which raw materials would be better suited for it. They went relatively, great distances sometimes to get those rocks, and understanding how you have to strike it at a certain angle to get off the piece of the proportions that you want, and to be able to repeatedly do that over time, gradually winnowing down this larger piece of flint or other rock. And then those pieces that come off, shape them into the handy point or knife or drill or whatever.
It makes me wonder if there were individual Neanderthals in a community that's like, I have the right rock, but I'm going to go bring it to so-and-so because they make that, they know what they're doing. It's if there were
the true crafts people.
Like you have a carpenter for an ancient village where it's like, I've mastered working with wood. If there were individuals that's like, oh, no, you want them to make it for you because it's going to be so much better if they do it.
So we do have some sites where there seem to have been individuals who weren't very good at it.
Okay.
And you find debris that is sort of the rookie mistakes that we see as living people learn to be flint nappers that they make, where you've kind of hit it at the wrong angle and you mess it all up and you can't get anything off of it, and you've just kind of bashed a rock into a state where you don't have any sharp edges, you just have a battered rock, basically.
Yes. You have to go find a new rock.
Yeah, or it ends up coming off too wide, so you couldn't use it as a point. And archaeologists have found this kind of debris at some sites, and they've interpreted it as, novices or individuals who were learning, maybe children trying and learning. But presumably, if everyone in your culture is making stone tools and you need them for all of your activities, we assume everyone learned. But that is a great point. I mean, like every task, I'm sure some individuals were better than others.
Yeah. Is it, everyone has to be able to do this, but they're the one that makes these, just everyone respects their skill. Like, were they known for it?
Also, when we were talking about the difficulty of identifying, is this a tool, is this not a tool, who's making this tool, the fact that some people just weren't as good at it is a whole other level of complexity to be like, all right, is this a stone tool that was badly made, or is this just a rock that happened to break into this shape? That makes it that much more difficult. Now, while we're talking about these distinctions between Neanderthals and our species, and as we are, it is inevitable for us to get into these discussions, I think, of trying to picture, what were their cultures like? What were they like as people? I do want to take a moment here and give you a chance to mention some of the things that people tend to get wrong about Neanderthals. Neanderthals are in that position that it's a sort of an exclusive list of ancient species that are so popular and so well known and so much in sort of the public eye that we can't help but for there to have been a whole bunch of misconceptions that have come up about them.
Yeah, they've been popularized and misused in that popularity.
Yes. So what are some of the ways that stand out that Neanderthals are now or have been misrepresented?
Well, there's, of course, the insult that one living human might give to another living human. Oh, you're a Neanderthal. You're a Neanderthal, meaning of low intelligence, brutish, not sophisticated. And that is certainly a stereotype of Neanderthals that I would push back on. And if someone called me a Neanderthal, I would say like, "Oh, why? Thank you."
Thank you for noticing the skill of my stone tool.
I would be humbled. But a big shift, I think, happened even in popular perceptions of Neanderthals around 2010 when they got a full genome, high coverage, so like well done, very numerous times over they read the genome of a single individual Neanderthal and showed quite convincingly that Homo sapiens interbred with Neanderthals. So Homo sapiens had sex with Neanderthals, and many people on Earth today carry some of that Neanderthal in their genomes, myself included. I haven't done the test, but based on my ethnic history, I'm confident I have about 2% Neanderthal DNA, as do
I have
most
done
people.
one of the tests, and I do know that I have Neanderthal DNA according to the test, which also makes sense given my background as well.
I want to do the test now.
You are almost for sure.
Yep. Oh yeah.
Look at you.
Yep.
So yeah, we can go into that genetic stuff in a bit, but I have to say, once a lot of living people realized they have Neanderthal DNA, like suddenly Neanderthals weren't so bad. Suddenly people are proud to have Neanderthal, and then they start saying like, oh, I mean, if my ancestors had sex with them 60,000 years ago, they couldn't have been so bad. They must have been. And they raised successful offspring because we still have this DNA that got passed down through the generations. Those offspring survived, so I guess they were okay.
That is a really good point. That because that makes complete sense that would have been a point.
Once it became personal.
Yeah, well, because beforehand, now it was a way to say, look at this lesser than group of humans that didn't, that surely was inferior to us, and they go, actually, they hooked up with them. Right. Well, then they couldn't have been that bad.
Right. Well, and produced your great whatever.
And that is a really good point. That would have caused that shift, because now you can't look down on them without looking down on your ancestors a little bit.
Yeah. Well, it's interesting, the parallels. So much of what, Bridget, you're explaining is the same thing that we've done over time with dinosaurs.
Yes.
The notion of the word dinosaur being used in a similar way as sort of an insult, something that's outdated or
past its
time. The notion, this old notion that this happened with dinosaurs, it happened with Neanderthals, that they're not around anymore, so therefore they must have been this dead end. They must have been inferior. They must have not been fit to survive. And then as time has gone on, not only have we learned more about them and what made them interesting and what made them dynamic and cool, but much like with Neanderthals, that there is still some of that around today. That we can look at something in the world today and go, well, yeah, that hummingbird, that's a dinosaur. Like some of our people, we have bits of Neanderthal. That heritage is still around today. And that helps to make it a bit more something that exists in our world alongside us that we can connect with, and really helps to overcome those really formerly very common misrepresentation of those groups.
Yes, definitely. And I have to say, where I live, we have wild turkeys, and every time I see one, I say like, "Hello, dinosaur."
Oh yeah.
Yep. I know that every year here in the U.S., when Thanksgiving comes around, the online sort of social media communities of paleontologists start circulating the memes of like how best to cook your dinosaur and the anatomy of your dinosaur.
Yep.
Yeah, we don't have similar, how to cook a Neanderthal.
No, we
Thank
don't.
goodness.
And it's funny because when we talk about, this is another one of those interesting aspects of discussing Neanderthals that differs from most of the other groups that we discuss here on the podcast, is that Neanderthals are people. They are humans. They are humans that, as we were just discussing, there's a bit of them still around in our own lineage. And that really does kind of automatically command a certain level of respect and reverence that we might not give to, when we talk about birds, when we talk about, I wonder what it tastes like. You end up being in a slightly different mindset when talking about ancient hominins, because, well, yeah, you wouldn't ask that about a human.
Yeah, because you can empathize potentially with them.
And it puts them in this very interesting category for us to be understanding.
I know that shift happened, and this is going to seem like probably a silly example, but that shift definitely, one of the earliest times that happened with me was the old Geico commercials.
So Neanderthal, a caveman could do it.
And then they would have the Neanderthal in just normal human clothing, living a modern life. And that was one of the first times I had that moment of like, yeah, that like you said, if they were time travel to today and we raised one in modern society, that's what they would be like. Is they would have those features, but
they would also need car insurance.
Yeah, they would just be a person. And that was really one of the first times it shifted in my head of like, yeah, it's just another group of humans, and that does really change. Just puts everything in a new perspective.
Oh, but I should clarify that if you talk to other anthropologists, you might get different answers about, could they do everything we could do?
Yes.
We're looking at the same evidence, and we certainly can't run an experiment where we actually see if a Neanderthal could use a smartphone or something. But, looking at the same evidence, people do come to different conclusions about this, about, okay, absolutely, we agree they were intelligent. They, survived through various phases of the Ice Age and last Ice Age in Europe. They, made complicated artifacts, and they hunted dangerous animals using cooperation, et cetera, et cetera. But did they have this kind of symbolic behavior? Did they make art? Were they, did they have as complex language as us? These kind of things will probably be debated till the end of time.
Well, and it also the point we make often of, what an organism is capable of versus what it did do, or what they would have been doing. Like maybe they didn't have that aspect of culture, but could they have if they were taught it?
Right.
Is
very difficult to do.
Yeah, exactly.
Yes, that comes up a lot with Neanderthals.
Yeah.
Yeah.
Cool.
So we've already begun sort of setting the stage for the world that Neanderthals lived in, where and when they're found. You mentioned that Neanderthals are found, the evidence of Neanderthals are found widely across Eurasia, right, throughout Europe into parts of Asia. What is the time span of Neanderthals?
Well, of course, Neanderthals evolved from earlier species of hominins, but you start to see fossils that have these distinctive traits that we only find in Neanderthals, which, analogous to the Homo sapiens chin, are just quirky little things that help us say, like, yes, indeed, that is a Neanderthal. So you start to see those around 250,000 years ago, 200,000 years ago. And that's when we see the kind of classic Neanderthal form that is this wrestler style, short and stocky, robust physique. The elongated skulls with some traits that are distinctly Neanderthal.
Mm-hmm.
And you find those fossils then, from about 200,000 till the last, I would say, convincingly dated Neanderthal fossils are about 40,000 years old.
Okay. Are there parts of this distribution in time or space where Neanderthals are particularly common? You mentioned a lot of the research has been done on them in Europe. Is there a particular part of their time or space distribution where they seem to have been peak Neanderthal?
Yeah, I think often researchers say classic Neanderthal. What you might think of like the Neanderthal heyday or heartland would be in Western Europe, Central Europe. And some of that could be a byproduct of number of excavations and having places that preserve fossils well, like plenty of mountains and caves with caves. But whereas in, the far eastern reaches of Neanderthal territory and into Southwest Asia or the Middle East or Eastern Mediterranean region, they seem to have evolved in Europe and then spread east during some periods and spread into the Middle East in some periods and then disappear in certain times. So it wasn't just Homo sapiens who are this, type of human that spreads out of Africa and marches across the continents. Neanderthals also spread out of, where they seem to have originally arose in their classic form. So a dispersing species as well. But yeah, it's fair to say that if you want to, if you were traveling back in time and you wanted to reliably run into a Neanderthal, I would check what is today Germany, Belgium, France, Spain.
Mm-hmm.
It's a good guess you're going to find Neanderthals there. And the places you find the last Neanderthals, so the sites that we have the latest dates for Neanderthals around 40,000 are like around the Balkans and the Iberian Peninsula, so Spain, Portugal, Gibraltar, and the Italian Peninsula. So these seem to be these kind of little refuges where even during the coldest phases of the Ice Age, Neanderthals can survive. And maybe farther north, they're going to disappear during the coldest phases and then repopulate them when it gets a little bit warmer. So I would, check kind of Southern Europe at any time, and you could probably find a Neanderthal.
Gotcha. And you started hinting at what my next question is going to be, which is, what do we know about the origins of Neanderthals? It sounds like we may have a sense of where they got started. Do we have a sense of who they came from? What of those other hominin species might have been the progenitor?
Yeah, pretty well. So I know a Neanderthal ancestor.
Yeah.
They come from a cave called Cima de los Huesos, translates to Pit of the Bones in Spanish. Comes from mountains of Spain, and this is a site that's has fossils that are about 430,000 years old, so older than we think classic Neanderthals are, and people have known about this site for decades, and it's has quite a lot of fossils for this time period. They found fossils from about 28 individuals. And over the years, they've carefully studied these. A lot of them are very crushed up, and they've refitted them back together, refitted together the skulls from all these different pieces. This site is pretty wild. It's found all the bones, why it's called Pit of the Bones. We're at the bottom of a 13-meter shaft and then kind of slid down a little slope in a place that's already 500 meters. So going around a track basically from the entrance, and, presumably in total darkness. So for some reason, there's this big pile of bones of almost 30 individuals that look like skeletons that could be male and female and humans of different ages. All this background to say that for years, they've looked at these fossils and said, okay, they have some of the traits that look like Neanderthals, but not quite all of them. So they still have some kind of more archaic features that you would see in earlier hominins or humans, but they do have a few of the features that we later see in the classic Neanderthals. So these, just more based on morphology, the look of the bones, seem to be Neanderthal ancestors, many anthropologists would say. But we got a second line of evidence at this very mysterious Pit of Bones, where in fact they were able to extract a bit, like 1% of a full genome of including nuclear DNA from some of these bones. And in fact, when they have the genetic data to show it has some of the mutations that you later see in Neanderthals, but not all of them. And so even genetically, they look like Neanderthal ancestors, some group that's on the branch that eventually leads to Neanderthals before they have, evolved into what we would call the classic form. So here we are 430,000 years ago, where there are some ancestors there that likely evolved into Neanderthals.
That's any of our listeners who have been listening to the podcast for a while or have listened to a lot of our episodes may have a sense of how cool that is.
Mm-hmm.
So often in our episodes, we'll talk about a group of animals or a species or whatever, and we get to this question of what were their origins like? Where did they come from? And so often the answer is, there's like 3 fossils that might be this thing because, of course, the earliest parts of a group's lineage, they were much rarer back then. They don't quite look exactly like themselves. They're a lot harder to find and recognize. So having a group, a lineage to talk about where we can say, what were their ancestors like? And we can point at a cave and go,
at a population.
This is exactly what they look like. There they are. Is an extremely nice thing to have. It doesn't hurt that they are a mere 400,000 years old compared to a lot of the stuff that we end up talking about. That makes it a lot easier for our fossil preservation over time.
But I had the exact same thought. It's very rare that we say, well, the ancestors of this group was this group. They're pretty sure this group led to... Usually the best we can do is go, well, this group is probably a lot like what their ancestors would have looked like.
Right, exactly.
And that's it. This is wonderful.
Now, that being said, I also know that's not the case for all hominins. Neanderthals are, like you were saying before, Bridget, a unique situation where we do know quite a lot about them.
Yeah, and so although it is like a mere 400,000 years old and change in that cave, it is the oldest human DNA that's ever been recovered.
Wow, very cool.
So there's older stuff from animals that got frozen in permafrost, but this is the oldest human DNA. Well, at least that's published or that I've ever heard of.
Yeah, tomorrow, perhaps, there will be a new paper that comes out.
If someone who listens to this episode is like, well, just wait.
And a few other things that are interesting about that site, but not really relevant to. There's only one artifact found there, and it's this beautiful red stone tool that's sort of teardrop shaped, and we'd call it a hand axe. So it's something you could hold in your hand, made out of this beautiful red rhyolite, and the archaeologists call it Excalibur. But no other artifacts, just this pile of bones at the bottom of a shaft, deep within a cave that would have been totally dark and away from sunlight. And when they reconstructed about 20 of the skulls, 17 of the skulls actually, and using the type of techniques you would use for forensic analysis of more recently dead humans, they had these wounds in the skulls that we call perimortem fractures, meaning that they were injuries to the skull that happened that probably caused the individual to die. And how would you know that? Well, maybe the bones did break later, but they're kind of the fractures that you would still need all your soft tissue to kind of absorb the blow, but still break the bone.
Yeah.
But they didn't start to heal. So the individuals must have died from that too. So the researchers actually think this group was killed, and then others deposited the bodies there. I don't know whether it was, their loved ones in a sort of funeral sense, or if it was their enemies that were like, oh, let's get rid of these bodies.
Thrown into the pit.
Yeah, that I can't say, but it was a pit of bones, and they seem to have some injuries on them that means they didn't die by accident.
Very interesting. Now, we've been talking about where we get all of this information from. Obviously, we've talked about the skeletons themselves, the DNA sometimes extractable from the bones. We've got artifacts. Are there any other bits of evidence that we use that you want to mention that we use in studying Neanderthals?
Yeah, so of course we find their bones and we try to extract as much information as possible from them. And because they're, not as old as dinosaurs, we can get organic molecules out of them. Yeah, including things like DNA and proteins, various carbon from within the proteins, that we could measure things like stable isotopes and get an idea of the proportion of their diet that is meat, or how high on the trophic level they were, these kind of things. We can do radiocarbon dating on Neanderthal bones. If they're 50,000 years or younger, that's the time frame that radiocarbon dating works for. So all of that, whenever we find fossils from Neanderthals, we're trying to extract as much information as possible from them. And we do have the benefit that organic molecules will preserve. Their bones are not totally rock. They have not, completely fossilized, if they in fact, died in a place with good preservation. We also have the artifacts they left behind, which are predominantly stone tools, but occasionally some other things like artifacts shaped out of bone, arguably a few beads, but not unlike Homo sapiens from this time, who are, for whatever reason, making beads like crazy out of animal teeth and ivory and shell beads. Neanderthals might sometimes do it, but it's not, you're not going to feel treasure chests with Neanderthal beads. You're going to maybe have a handful that have ever been arguably found.
Interesting.
And then, of course, we also have leftover from their meals.
Sure.
So animal bones, butchered animal bones from prey that they killed and ate. And we can see things like cut marks on the bones to know they did, in fact, chop up these animals and eat them, and cut marks in places where you would be cutting off pieces of meat and cook them on a campfire. We have campfires that have preserved traces of their ashes with burned clay, heated clay around it. And we can, as we go into the microscopic record, there's lots of information that can be gleaned. For instance, on Neanderthal teeth, just like when you have plaque, and then if it sticks around, it turns into tartar, which is fossilized plaque, or also known as dental calculus.
Yes.
People look at the dental calculus, they scrape it off Neanderthal teeth, who fortunately did not have, regular dentist appointments, it seems. And they can look at microscopic bits of food that have, for 60,000 years been trapped in Neanderthal teeth, and see things like, oh, indeed, they ate plants, because I see, this little microscopic bits of plants that have survived in their teeth. And I see, and they can also get DNA from the dental calculus and other molecular measurements to say, oh, I see these animal proteins. I see, basically whatever they were eating is going to get trapped in their teeth and leave some kind of trace.
Yeah.
A very cool angle to study. And it does make me think of a question that I just thought, I hadn't thought about this before. I know that for Homo sapiens, for our own lineage, there are places in the archaeological record, paleoanthropological record, where we can get coprolites, where we can get feces remains, latrines essentially. Are there latrine or feces remains for Neanderthals?
Yeah, there have been some studies on Neanderthal poop, and they've looked at remains in them.
Cool.
It's not the most common thing to find, and there are other ways to kind of get at the same question. But certainly, if you're excavating and you find coprolites, archaeologists keep it. Every coprolite I've ever found has been from hyena. I find so many hyena coprolites. I never found a Neanderthal one, but other people have been more lucky than me and have found Neanderthal poop. And yeah, so it happens sometimes, but there are other ways to kind of get at their microbiome, for instance, by looking at their dental calculus. And you might be able to answer that same question by looking at their fossilized poop. The other problem with coprolites, if you want to do kind of DNA study, is they're more porous, so more recent things can be leaching into them. Organic material can be leaching out of it. It's not a really good reservoir for protecting the DNA and not letting in other DNA, whereas something like dental calculus is like fossilized plaque. It's really hard, and
right.
If it's on a Neanderthal tooth, you're pretty sure it's belonged to that Neanderthal.
So there is abundant evidence to use to interpret the lives of Neanderthals. Is there anything else that we've talked about that there's more to say about?
Yeah, probably something that's important is I told you about some Neanderthal ancestors, the Sima de los Huesos hominins. Most people call them the Sima hominins for short. But you could also ask, okay, who were their ancestors? And of course, you could
Mm-hmm.
keep asking this, but the kind of longer evolutionary history of Neanderthals, which is based on when genetically it seems that we diverged from them. That puts it about 600,000 years ago. And we could say, okay, where are any hominin or human fossils at that time? So we seem to share an ancestor with Neanderthals about 600 to 700,000 years ago. And most likely that ancestor was in Africa. Some group of them move out of Africa, some subset of this population, and they eventually evolve into Neanderthals going to the west, into Europe, and the ones that go east eventually evolve into Denisovans, this other type of human that we don't need to talk about now.
That's another episode. Put in your request now for an episode about Denisovans.
Link down in the description.
And then the ones that stay in Africa evolve into Homo sapiens. And, we have fossils from these things that, before we have any ancient DNA or anything, do in fact look like, the right size and shape and height and brain size for what you would expect to be the immediate predecessor to a branch that leads to Neanderthals and a branch that leads to Homo sapiens. And along those branches, they do look kind of similar. Brain size increases, the artifacts get a little more sophisticated, and then, eventually we get to about 300,000 years ago, 200,000 years ago, and in Europe you have these classic Neanderthals, and in Africa you have these classic Homo sapiens. So that's kind of longer story of, when do our branches meet and when did they split?
Fantastic.
I guess I would just say it's like a beautiful natural experiment of what happens if you were to take the same starting stock and like put it into two petri dishes, one in Ice Age Europe and the other in the same time period in Africa, which, yes, it had cold, wetter and drier periods, but as a hominin or human, it's always a good place to be living. Whereas Neanderthals are gonna, evolve different behaviors and biologies, living sometimes in very harsh, cold conditions, and then sometimes more temperate conditions, and then like bring them back together around 50,000 years ago, see how they differ. So, Earth has given us a great experiment for what humans can be.
Yeah.
We talked about this way back in episode 18 when we talked about human evolution. We brought up the fact that so often when we're talking about the geologic record, the fossil record, we often focus on how much we get caught up on incompleteness in our record, and that there are all these questions that we can't answer because the record is incomplete. And that is certainly true that there are major gaps in our understanding of hominin evolution. But one of the themes that came out in that discussion is how surprisingly, astonishingly thorough our record of hominin evolution is. Like, there's tons we don't know, but there is so much information and we have so much detail about so many of these different species. It really does outshine basically any other group in the geologic record. And it lets us answer questions about who came from what and what species gave rise to where and how these species evolved in parallel. It's really, really a fascinating field to get into because there is all this information there.
Yeah.
Well, we've talked a whole bunch about who Neanderthals are, what their record looks like, what sort of their environment, the evidence, all that sort of fascinating background information. After the break, let's start getting more into the topic that we basically never get to go into in episodes of our podcast, and that I'm sure our listeners are very excited about. Let's talk about what we know about Neanderthal culture. Stay tuned for that.
Cool.
So as we move into talking about Neanderthal culture, I think an obvious place to start is technology. And we've already hinted about this a little bit. Technology seems like it's one of the main ways that we get to understand Neanderthal culture. So can you tell us a bit about what sort of technology did Neanderthals use?
What we know about Neanderthal technology mostly, but not exclusively, comes from their stone tools, but the same could be said for Homo sapiens 100,000 years ago or so. And actually at that time, if we went back 100,000 years, during kind of the heyday of Neanderthals, Homo sapiens are around as well, mostly in Africa, but both groups make it to the Middle East around this time. Their technologies are very similar, and this is what we call Middle Stone Age or Middle Paleolithic. And you know enough about the physics of rocks and the artistry and craftsmanship necessary to create weapons for hunting and maybe for war, but we could say definitely weapons for hunting for domestic chores, domestic tasks like cleaning up that animal that you've killed and cutting down wood to use in the fire and maybe building little shelters, whatever you have to do with that you need a sharp edge for or a sharp point. So a knife or a spear or any of these kind of things. Those we can glean from the stone tools because they made knives and scrapers and spear tips out of stone. And so they had pretty sophisticated processes to do that certainly they must have been teaching each other. Because again, if you try to invent this on your own, even if you're watching others, it is pretty difficult. So based on how complicated the ways they made their tools were, how they took a big chunk of rock and crafted it down, sculpted it down, knocked off pieces to shape into usable tools, based on the way they were doing that, they seem to be teaching and learning, which is pretty advanced, right? We know there's not that many animals that exist that teach and learn. Mm-hmm. And recently they've discovered some other technologies they have they're pretty fantastic. And the one that I would like to emphasize is string.
Oh yeah, I remember seeing this.
Yep.
So far, the evidence comes from one site, but this is also where they thought to look from it. And this is not like they dug up big ropes that were discovered, but they found microscopic traces of fibers that were kind of stuck to stone tools that kind of just happened to preserve these little bits of fibers. And then looking under the microscope, we're able to see, in fact, these fibers were what we would call string, which means that they took kind of plant fibers and they twisted them, they folded them in half, and then they let them twist again. And in fact, they did it in ones that they discovered. It was like 3-ply, which is kind of difficult to make, and seemed to be made out of bast, which is this kind of inner part of bark. So Neanderthals must have known that there's this soft fibrous stuff within a tree that if you harvest it in late spring, early summer, it's easier to harvest. When the sap is coming through, you have to kind of soak it in water for a week or two, and then you get these fibers that you can then twist and fold and let twist again in order to have this like usable string. So they found some traces of this. So far, the evidence comes from one site in France, but maybe, looking for these microscopic traces, people will find more. And that's really advanced technology, actually, because so much of it is invisible, like knowing that you can get these fibers from within a tree and knowing that you have to let them soak and knowing that you have to twist it to make something that's so far removed from a tree, right? Like looking at a string, you wouldn't think, oh, that comes from tree, right? You would have to be taught that. And, if we find more sites over time and showing that this is passed down to over generations, that would show, intergenerational learning. And so little things that might not seem like very advanced technology actually take a lot of cumulative culture, so building up knowledge over time and passing it down that like no one individual could probably have invented themselves.
Wow. And you said that these fibers were found attached to tool or like on a tool. Is that like the tool was used to cut the fiber and there's residue, or the string was being like wrapped around the tool or something like that?
To connect it to something.
We don't know exactly, and it might just be a kind of fortuitous preservation, like maybe the string fell on the ground, the stone tool fell on top of it, it got buried that way, and it protected it in a little microenvironment. I mean, so far they found it kind of just stuck to stone tools, but I think, we might see more as people start looking for these. You might see like a fiber on a stone tool, which is like, oh, what is this?
But now that we
and flick it off. Yeah, because these are kind of like, the size of an eyelash. You have to look at the tool under the microscope and really investigate, like, oh, in fact, this is twisted and it has multiple strands to it.
Yeah.
Another example of really sophisticated technology is the way they produced birch tar. And birch tar is a natural glue that comes from birch trees. And it kind of distills out and it's sticky, and, you could use it to adhere things together. Or if you had let's say, a sharp stone tool and you wanted to make one side so you could grasp it and the other side stay sharp, it could be used to make a handle like that. So a very useful natural adhesive. To get it out of the bark, I mean, once again, you need to know this stuff exists in a tree. There are different ways to do it, but based on some chemical analyses of chunks of birch tar that have been found at Neanderthal sites and kind of how it seems to have been extracted from the tree, it seems that they put birch wood underground under campfires and were heating it in a low oxygen environment and then catching somehow the birch tar that drips out and then solidifies into this like nice sticky adhesive. And again, this is something that they must have had like basically research and development R&D over years, and have little by little learned the steps of this process to kind of improve it from simpler methods of doing this to this kind of like underground, invisible process that must have been taught if, they, eventually did it more than once.
Yeah. These kinds of discoveries fit nicely in that category of things we were talking about before, of things we have been learning in recent years about Neanderthals that have really challenged those old ideas of them being sort of primitive and simple and brutish and whatnot. Finding these things that we are very classically inclined to look at and go, humans do that, and human means us, and therefore it must be us. That Neanderthals were using these really advanced technologies is really fascinating.
Yes. Well, and I love learning about these things, with early Homo sapiens and Neanderthals, because I love thinking through like what was the situation that led to the initial discovery. Mm-hmm. Did someone just burn a piece of the wood and then go, why is the campfire, like, we put it out but it's sticky, and then now you have someone who asks that next question and takes that next step. And like you point out, that string seems simple, but is actually a fairly complex thing to make. Like, especially they're having to do it by hand. Like, most people just buy string. You don't ever think about how it was constructed. But like, I've done some twining just because I'm bored.
My understanding is that it falls out of spiders,
right?
And then you put it on your crafting table and it goes together.
And like, it brings up the question of, did you have something else you were using to do the job of string before that, or did someone come up with that? Was that a new technology truly? Because so many of the things we invent nowadays is based off of a pre-existing version of it, and we go looking for the new thing, the new version of it. But some of these could have been the first time some groups of humans were doing these things.
Yeah,
and that's cool.
Yeah, and presumably they could have been, like weaving long grasses to make cords or cordage or baskets. Unfortunately, none of those have survived in a way that we can detect it. But we do have some sites where when they excavate within a cave, they'll find a certain area where there's really, at a particular level, there's really high concentrations of microscopic plant remains from grasses that don't seem edible, and not the edible parts of plants either. But the interpretation is that they were probably bedding. So they're bringing in these soft, plush plant materials that you wouldn't eat. They're not cooked, but laying them down for bedding because, you want to make your cave home as comfortable as possible.
Very cool.
Well, that does lead, starts to get us into the questions of what are the various things they're doing with these tools. So much of the discussion of their tools is things that are cutting and stabbing and or being adjacent to the things that are cutting and stabbing. So the next question that I want to ask to you is, what did Neanderthals eat? So much of what we understand about their lifestyle seems to revolve around their food source.
Probably a misconception that still exists, maybe even among some archaeologists as well, is that Neanderthals were primarily big game hunters. And
that is sort of the classic image of them.
Yeah. In fact, if you do a Google search, you'll probably see this silhouette of a Neanderthal with a spear and a woolly mammoth like on its hind legs being attacked by it. I've seen that image many times. And well, first of all, they're probably hunting in groups. So I don't think a Neanderthal would just independently go up to a woolly mammoth.
Yeah.
It seems like a bad idea.
Yeah, with one spear, one
Right.
handheld spear.
You brought a spear to a mammoth fight.
But, because of these abilities to probe the microscopic record with things like looking at their dental calculus or tartar, we can see indeed they ate plants. And indeed, when we look at the smaller bones that are excavated at a site, they ate smaller game. And fish and things that for a long time, one idea about why did Homo sapiens survive and Neanderthals go extinct that has been proposed over the years is that Homo sapiens had more diverse and flexible diets. Yeah. And Neanderthals were these big game hunters. So, if the megafauna start declining, so do the Neanderthals. The poor humans could not eat anything else. But that seems kind of silly, even looking at our closest living relatives, chimpanzees. They eat diverse diets. They eat a lot of fruit, but they also eat other animals. They eat monkeys and, shellfish and ants. Yeah. So probably Neanderthals ate diverse diets, and we do have the evidence now from these more microscopic remains as well. And some that look like they were cooked, so cooking their food as well. And, just like humans today, what you eat probably depends on the season. It depends on the environment. It depends on where you're living. So when they were living in the worst phases of the Ice Age and this kind of environment known as the Mammoth Steppe, so you can imagine like frigid kind of grasslands with mammoths roaming, they probably ate a lot of meat.
Right.
Because that's what was easy to find. Like, I don't know, maybe you find some blueberries or something occasionally in the spring. But and then when it's warmer, more temperate conditions, they probably ate the bounties of the forest and the sea.
Yeah, I think we had a news that we discussed not too long ago, if I remember correctly, that was evidence from the skulls of Neanderthals potentially diving or spending time in water. And one of the implications, one of the potential interpretations that was suggested was that they may have been foraging for food, collecting shellfish, and things like that.
And I think there's a mention of like shell remains of like a particular site that I can't remember the details.
Yeah, I did see that news. I didn't actually look at the study, so I can't say much detail of it. But I wouldn't be surprised if they could swim, as well as we can swim.
And like you said, diet, especially in species like our species that are so versatile in our ability to take advantage of our surroundings, diet is going to depend a lot on where you are. And if you live on the coast, there's all sorts of food in there. It only makes sense to go in there and start collecting what you can.
It's an interesting idea, the old premise of them being apex predators primarily, big game hunters, because that would make them unusual among primates in general.
That's true.
That would make them very weird if that was the case, just among all primates. And so the fact that we found out that that's not the case, it's like, okay, that makes much more sense.
You're seeing more and more normal.
Yes.
So you mentioned, we were talking about tool creation. You mentioned Neanderthals would have been hunting, gathering food, foraging food in groups, which leads very nicely into another important question about Neanderthal culture. What do we know about the social lives of Neanderthals?
Yeah, so it's ideally you would excavate a cave and find a big group of Neanderthals who all died at the same time and really have a snapshot of like, oh, this is what a community is. And, there hasn't been that many cases where we find a huge collection of Neanderthals who all seem to have, died at the same moment, providing us this view of like Pompeii. Okay, this is what they were like in action.
Right.
But there have been a few cases where a recent study that came out in 2022, about a year ago, they did look at two caves that are relatively close together in southern Russia and Siberia. And they're about 50,000 years old, and probably in an area where they were doing bison hunts and would come to these caves seasonally to hunt bison whenever they migrated there. And they do seem to have, a family there. They have individuals that all look to have died around the same time, perhaps the same year, of different ages, of, the skeletons, some look male, some look female, and they got genomes from them from about 6 adults and 7 younger individuals. Based on the genetic relationships of these individuals, some seem to be as closely related as cousins. There's a pair that could be, they share about a quarter of their DNA, so they could be an aunt and a nephew, for instance. And there is a pair that is a father and a teenage daughter. And all these individuals, might have died the same week or year or 10 years, and their remains wound up in the same pair of caves, and predominantly one of the caves. And so, okay, we can start to ask questions like, yeah, that is a family. We know, it shouldn't be a surprise that older individuals are with younger individuals.
Mm-hmm.
Other primates raise their young. Many mammals raise their young until they can venture off on their own. And all humans we know basically live in groups.
Mm-hmm.
But some other things that could be said from that was they found that looking at the Y chromosome, that's only passed down the male lineage, and comparing that to mitochondrial DNA, which is a small loop of DNA that's only inherited down the maternal line, so passed on from mother to offspring. So comparing this mitochondrial DNA with the Y chromosome was much less diverse. And then the female inherited line, the maternal inherited line, was more diverse. And so that pattern suggests that, at least in this Neanderthal community, over time, the males might have stayed in the group they were born into, and the females might have left and joined other groups.
Gotcha.
And then, had offspring in those groups.
Right, which is a pattern that we see there are human cultures where things like that happen, but also in other primates.
Yes.
Where things like chimps or bonobos will have their core group, and then certain individuals at maturity will go off and find another tribe to be with or something like that, or another troop to be with or something.
Right. So, but this is, from one time and place that Neanderthals lived.
Right.
So I don't know if Neanderthals, like in what is now Armenia or what is now Portugal or what is now Italy, were behaving the same way. So it'd be awesome if we could find more sites like this where there's like a group of Neanderthals that indeed seem to die around the same time, and we can show their actual genetic relationships, that they had family ties, and then kind of ask these questions of, how many youngsters are there? How many old ones are there? And do there seem to be any patterns of who stays and who goes?
Mm-hmm.
Yeah.
And then another place where we sort of have a snapshot of a community is a very cool site. That's the beaches of Normandy, but, well before D-Day.
Sure.
About 80,000 years before. There was groups of Neanderthals there, and the sea was a little farther out, but basically they left their footprints in soft mud that quickly had sand blown over it. And so beautiful, like hundreds of footprints have been preserved there. And in the 2010s, archaeologists excavate them, but as soon as they uncover them, they basically get destroyed. So they documented them as they went. And looking at ones that were all seemed to be deposited in the same fine layer, about 100 of them all probably left within a matter of a few days. They could, based on the size of the footprints, say there was, about 10 to 13 different Neanderthals with a few adults, and then mostly teenagers or individuals who weren't fully grown, and children. And so, yeah, there was, mostly youngsters in that group. And at the same site, they found the kind of debris of normal life, like butchered animal bones and stone tools. So assuming the individuals who left the footprints also left the stuff, it seems like kids and teens were participating in the tasks of being a Neanderthal, contributing to the hunting and gathering and preparing food and preparing fires and all the things you need to do as a forager.
That's really cool. That's great. That's a great type of evidence to find.
It's really interesting getting to get to see that family group evidence, but it'd be something much closer to what we think of when we think of a family group,
right?
Like, because we talk about evidence of group living in others, organisms and other animals, and this is one where it's like, no, I've been on a walk similar to that,
right,
with my parents and siblings and friends.
Yeah, and I'd love to say they were like playing on the beach, but we do know the sea was a little farther out, but not too far. So maybe they also went and played on the beach, but now that's covered in water, so we don't have those footprints.
Oh, sure. Well, that thought that you might see, I've seen this kind of evocative phrasing used of this beach, right? You are playing on the same sand that young Neanderthals played on 80,000 years ago. And yeah, I could totally, absolutely imagine young Neanderthals like chasing birds around or like throwing rocks into the water. Because, that's the kind of stuff that you do.
Yeah, and again, like all young primates play.
Yes.
Most young mammals play. So I'm sure Neanderthals played.
Absolutely.
Yeah. Well, speaking of playing, I also want to make sure that we talk about another category of cultural living, which we're kind of moving progressively in the direction of things that are harder and harder for us to say.
Yes.
For sure. But what do we know about Neanderthal art and expression or language, these sort of, this more artistic side of their culture?
So we know that some early Homo sapiens that get to Europe by about 35,000 years ago, for whatever reason, they decide, it's very cool to paint amazing realistic images of animals inside caves. So there are these very famous rock art caves in mostly Spain and France that, Lascaux and Chauvet, you can look up YouTube videos of them, are just breathtaking. And I mean, that's probably what got me into archaeology. I don't mean to diminish how exquisite those are. But it is kind of weird to like go in a cave and paint the walls, right? Like that's a lot of time and effort that you could be, foraging for food or taking care of your offspring or whatever, right? So, and it's not like Homo sapiens are doing that everywhere. Like around the world, we find artwork where, images have been painted on caves and rock surfaces. But again, that's like a very good place for art to survive. And it's just one way to make art. And if we look around at all the different ways that humans make art today, they dance and they paint things that disintegrate. And even, sometimes cooking can be a form of art. So there's many ways to have artistic expression. And the other kind of early Homo sapiens art that we find is beads. So we find shells, teeth that have holes carved into them, ivory that's carved into beads, and sometimes arranged on a skeleton, as you would expect a necklace or, clothing to be. And so, no doubt that starting about 100,000, 120,000 years ago, Homo sapiens love beads. And by the time they get to Europe and stay there, they're just like making beads like crazy, whatever. They're probably like, we're the fox tooth people and we're the mammoth ivory tusk people. And like, this is what we like to wear. But again, that's like a weird thing to do. Like spending all this time carving this little thing and putting it on some kind of string or pendant and wearing it. Like what? Why? Why are you doing that? So, that was our way of being symbolic. And so typically archaeologists have looked at for those things and they don't find, Neanderthal beads, maybe a few, as I mentioned, but it's always like towards the end of when Neanderthals existed, after Homo sapiens get to Europe. So maybe they just copied them or maybe they stole the beads from them. You can't say they were independently invented. And then there are some sites where there are some painting, in particular, 3 caves in Spain that they, did a lot of dating to show this is Neanderthals painting caves, but it's kind of like abstract red let's call them finger drawings.
Yeah.
They're not as impressive as the later stuff you see with Homo sapiens in the same region. Okay, so how could Neanderthals be symbolic? One line of evidence that I find pretty convincing is at many sites across Neanderthal territory and time, they find bones from birds of prey that shows they were cutting off their feathers. So like wing bones that have been cut in a way to suggest they were cutting off their feathers. And they're not the type of birds you would want to eat. They're typically like corvids, raptors, things high up the food chain that are difficult to catch and like not very good to eat anyways. I've been told. I've never tried them. And so it seems like Neanderthals were using feathers, and I think it's a reasonable hypothesis that they were decorating themselves with feathers, and then the feathers themselves disappeared, disintegrated. What we have left is the bones they cut them off from. So some would say, oh, they were actually using the feathers to fashion them to their spears or something, or make shelter. Okay, maybe. Or, maybe they were decorating themselves with feathers, just like Homo sapiens decorated themselves with beads.
Yeah.
It's so hard to know with, especially things like that, because so much of it is so ephemeral.
Yes.
You made the great point that we find these paintings of Homo sapiens in caves, and it raises this question of like, what was it about caves that you wanted to paint in caves? And there for sure can be special things about caves, but also caves are where they preserve.
Yeah, you could have been painting rocks all over.
Yeah, if you painted a tree, it may have been the most beautiful painting in the world, but when that tree, we don't have that tree anymore. So artistic expression can be so difficult to interpret because it's so often using materials that don't preserve. And then also, like you were just getting at, it's so often difficult to interpret.
Yeah.
To say, all right, you were using feathers for something, and there's all sorts of different answers to what that something might have been.
Was it practical? Was it to look neat? Was it to symbolize something?
And the reason I myself get so excited about beads, Paleolithic beads, is because it does imply very sophisticated symbolic thinking. Like if I'm gonna wear this thing, I mean, think of all of the reasons that humans today wear jewelry. It might symbolize, a rite of passage, like getting married or, killing your first bison or graduating college. It might mean you belong to a particular ethnic group or family line. In order to be wearing that, the other people have to understand that. In order to understand that, you probably have to have language. And so beads are one of those things that's like, if they are repeatedly making beads out of the same materials in a consistent way, they probably have language.
Yeah.
And but another and symbolic thought and like these kind of higher level imaginations. So the other area this really comes up is religion, thought, beliefs in the afterlife. So did Neanderthals do that? What we can say confidently is between about 130,000 and like the end of Neanderthal, we do have about 30 sites with Neanderthal burials where clearly someone who was alive dug a hole, put a dead Neanderthal in it, and covered that hole. And as an archaeologist, that's pretty easy to tell because the bones are articulated, meaning they are in the position they should be in a living human. They're pretty much all there most of the time. So meaning they were quickly buried. And the sediment around it, you can imagine it would build up over time in these nice layers. But if you dig a hole and then fill it back in, the sediments can be all kind of jumbled without orientation. So distinguishing a pit that's been dug into like nicely layered stuff is pretty easy to do.
Yeah.
So we can definitely say Neanderthals sometimes buried their dead. And around the same time, Homo sapiens also start doing this, at a couple dozen sites around this time period. But they're not burying it with a bunch of artifacts or grave goods, as we would call them. They're not like putting all these precious things and offerings in with it. For whatever reason, they're digging holes and putting dead bodies in them. So some people say, oh, is it just to get rid of it because you don't want a dead body around? Is it because you don't want the smell around and you don't want to attract scavengers? Or do these Neanderthals believe in the afterlife and think, we're going to bury grandmother in this important place where this is a cave we come to once a year and we will, give tribute every time we come? That I can't answer, but I can say they did sometimes bury their dead. And at some other sites, we have evidence of cannibalism. So they sometimes seem to have eaten their own kind. But Homo sapiens have done that too for various reasons. So
and I think cannibalism is one of those things that gets a rougher reputation than it deserves in many cases, where we often think of cannibalism as being, it has that same misrepresentation of being something that is brutish or uncivilized or whatnot. But in many cultures, it is a spiritual thing. It is a part of their religious beliefs or spiritual beliefs. So that seems like it has a similar case of this could be something they were doing for practical reasons. There's like, all right, here is some food, but it could also be something that was deeply culturally significant.
Yes, and especially because this is, varies across time and space. So it's not like they're always eating each other or always burying each other, but we see different times and places, these different cultural practices, which to me implies there was something more to it. Like they decided in that community, this is what we should do.
Yeah, it's a fascinating conversation, the question of Neanderthal culture. And what it always sort of seems to bring up and stick in my mind is it is very difficult to say for sure what Neanderthals were doing in their day-to-day lives, but it is very easy to imagine and very easy to explain them doing basically anything that we understand Homo sapiens to have been doing. It would make total sense that they were doing all sort of similar things.
Yeah.
Are there any other things about their culture that we want to mention before we move on to other topics?
I think that's kind of the high points of it.
All right. Well, great. Well, that allows us to move in to a last major section of our discussion, which is a section that I have very selfishly entitled Neanderthals and Us. This is a big question in research into Neanderthals especially, is the question of how they were interacting with our own species, Homo sapiens. And we've already hinted at this a little bit. What do we know about how Neanderthals interacted with Homo sapiens?
Well, we do know they sometimes mated successfully. And for the genetic evidence for interbreeding or sex between Neanderthals and Homo sapiens, that's from looking at ancient DNA and fossils to understand what the Neanderthal genome is, looking at living humans who have some of those segments that are distinctly Neanderthals, variants that you see in Neanderthals and don't generally see in Homo sapiens. And then also we have fossils from ancient Homo sapiens that have some Neanderthal segments and then ones that don't. So all of this is coming from genetic evidence.
Mm-hmm.
But it's not like one crazy night a Neanderthal and a Homo sapiens got together and that's why we have this genetic evidence. There were different periods or episodes of interbreeding where, maybe for decades or centuries or even a couple millennia, these groups might have been overlapping in a certain region, interbreeding. I can't tell you what the nature of that was like. I mean, was it consensual? Were they living totally as one community and raising offspring together? Was it more like rape or, occasional passing by and running into each other? And then the child would be raised in one community versus the other. Those kind of questions, the evidence is not available for yet.
Yeah.
Maybe eventually with kind of patterns of DNA, if it's mostly on male inherited Y chromosomes or mitochondrial DNA, we might be able to kind of get at those things. But currently, I can't say. But my take on it is that Neanderthals were not all in communication with each other. They're living across thousands of miles, and a Neanderthal in what is now France never met a Neanderthal in what is now Uzbekistan. And so they probably had very different interactions with Homo sapiens because they didn't have an official policy of this is how we treat Homo sapiens, and vice versa. The different groups of Homo sapiens are spreading across Eurasia and they're don't even realize they're going to be meeting Neanderthals because no one has called them and warned them about it.
Yeah,
right.
And so I imagine in different times and places, the interactions varied. Sometimes they probably got along, particularly if there was abundant resources. Maybe sometimes they did directly competed or fought each other. And maybe other times, they avoided each other. And sometimes, for instance, in the Eastern Mediterranean, what is, today, Israel, Palestine, Lebanon area, it seems that Homo sapiens get there first around 100,000 years ago. Neanderthals come in around 70,000 years ago and maybe push out the Homo sapiens, and then later Homo sapiens come in again. So it's not always Homo sapiens are victorious.
Right.
And another case, a site that has been excavated for about 3 decades, but has recently had some great publications. They find basically this really deep, many layers of Neanderthal artifacts, as well as some teeth from Neanderthals. And this goes on for about 40,000 years. But within this, 40,000 years worth of Neanderthal materials and fossils, there's one thin layer where the stone tools are totally different. They're these super tiny points that seem to have been used as projectile weapons and possibly bow and arrows, and a tooth from a Homo sapiens. And this is in a layer that's 54,000 years old. So this is a cave called Mandran in France in the Rhone Valley, where it seems like a group of Homo sapiens got there. There were still Neanderthals in the region. They survived for a couple generations and then they disappeared. And then Neanderthals, lived there for another 10,000 years or 20,000 years or so.
Wow.
So they were sharing habitats, even sharing, caves or specific sites.
Well, and I like your point that they weren't all in contact. And I thought of this when you were mentioning we have one population that may indicate how individuals were staying or leaving, the family group, but that we don't know that's what they were all doing. And I think that's always an important thing to remember when talking about Neanderthals or early Homo sapiens, that we now also are dealing with culture, and trying to say this is what Neanderthals did would be like saying this is what people did in the 1950s.
Right.
Like different populations could have had different practices and different, customs and different thoughts and feelings. So one group meeting Homo sapiens might have been completely fine. Another might have been completely hostile. Like you can't just say they were all doing one thing. They were complex, just like humans are complex.
Yeah, absolutely. Well, on the note of the question of how Neanderthals and humans interacted, we've talked about genetic swapping. You sort of hinted at the idea of them maybe stealing or copying tools from each other since they're in the same space. But it seems like probably the biggest topic that this question ends up revolving around, especially when the subject comes up in more popular spaces or more popular writing, is the question of what happened to Neanderthals.
Yes.
So as we approach the end of our discussion on Neanderthals, let's address the question of why did Neanderthals go extinct?
So people have put out so many different hypotheses for this. You can pick some more wild ones, like they ate each other's brains and they got the equivalent of mad cow's disease, but from
classic zombie
brains.
Apocalypse.
Yep.
Yeah, tracks.
So you can find at least one research paper that proposes that, that Homo sapiens brought in new diseases that wiped out Neanderthals.
Right.
These are things, that could be answerable. We can get ancient pathogen DNA, but aren't well supported at this point. Was it climate change? They were, the megafauna went extinct and so did the Neanderthals. Well, we know they ate more diverse diets, so I feel like they could have dealt with that. But the kind of elephant in the room is Homo sapiens. So soon after Homo sapiens get to Europe, and the group that successfully stays there and does lead to present day, in some cases with genetic continuity, gets there after 50,000 years ago, and within 10,000 years Neanderthals go extinct. So I can't deny that.
Yep, right.
That Homo sapiens
it looks
might have
suspicious.
Homo sapiens might have had something to do with it. We don't have any evidence of them directly killing Neanderthals, like a kind of equivalent of a smoking gun, like a Homo sapiens style stone tool found in a Neanderthal skeleton. That has never been found. We would sure like to find it. But anyways, that would mean one Neanderthal was killed.
Yes.
Not the whole species.
Right. Phil was driven extinct by Homo sapiens.
But, evidence that has been building up over time. And, if you have to ask me today, maybe I'll change my opinion in 10 years as more evidence accumulates. When we look at the genetic data, which now comes from about, 3 dozen Neanderthals, we have genome-wide data from, about 30 of them. And they come from different times and places. They all have pretty low genetic diversity. And there's various ways you can measure that, independent ways, sort of looking at the genetic data. And consistently, they have the type of low genetic diversity that you would see in endangered species today. And so it seems like, perhaps Neanderthals were always kind of on the brink, and considering they lived in Eurasia during the different phases of the Ice Age, maybe during the harsh times, a lot of individuals died off and their populations got small. There's evidence in their genomes for various bottlenecks in their evolutionary past, suggesting they went through these periods when they had a small population size, and then it might grow again, and then, come another ice age, shrink again, and then they build up again, leading to low genetic diversity species-wide and perhaps low actual numbers on the ground. And, with a small population, with periods when a lot of individuals die off, you can't build up as much cultural diversity or innovations as well. But in the meantime, like, in our other petri dish in Africa with Homo sapiens, they do come out of Africa numerous times and seem to fail in Eurasia. We have fossils from Homo sapiens around 100,000 years ago in the Middle East that don't seem to go anywhere. And we have some other evidence of kind of early Homo sapiens that leave Africa but don't lead to present day people. Whereas the ones that come out after 60,000 years ago do have genetic continuity with living people that spread throughout the planet to Eurasia, to the Americas eventually, to Australia. And so this group has long and always been in Africa for the evolution of Homo sapiens, where they could be building up numbers, building up genetic diversity, building up cultural diversity, inventing things that stay and stick. And so I think it might just be kind of a demographic argument, and demographics meaning, biological diversity, but also cultural diversity. And Africa was just always a good place for humans and hominins. And so by the time these Homo sapiens come out of Africa, Neanderthals are already kind of an endangered species. And maybe it was just like a final straw. Like, here's this competitor that comes from a more genetically rich background, and they also at this point have invented projectile weapons, and they're killing prey quicker and more safely than we can with our thrusting spears, and they're killing us sometimes with their projectile weapons. So I've heard people describe it as like a perfect storm. There's probably a number of factors, but those factors have to apply to all Neanderthals because, they do in fact all go extinct, but probably once their population got past this threshold, it's just like, every species that goes extinct, every endangered species eventually gets below a number where they're just not viable anymore.
Yeah. We talk about this a lot on the podcast when the question of extinction comes up, is it's always very tempting to try to find the one dramatic event that caused the extinction of a species. But so many times it's just a gradual decline, or it's a series of things. Neanderthals go extinct during this period of time that we have also discussed before, where we see lots of megafauna going extinct at the end of the Ice Age, which has all those species have gotten tied up in these same questions of what are the factors that drove mammoths and ground sloths and glyptodonts to extinction? How much was it our fault? How much did Homo sapiens have to do with this? And often it can be difficult to say for sure, because realistically, it probably is that there were lots of reasons why various species were struggling in different contexts.
I actually have a question on the note of their extinction, because I've heard this, but I've not heard it consistently. So I get that there's probably either debate or that this was suggested, but not with a lot of evidence behind it. The idea of the Neanderthal genome just basically being consumed by the Homo sapien genome through interbreeding. Very much the same threat that we've talked about for with the Cuban crocodiles today, that when they breed with American crocodiles, the young just look like American crocodiles. Right. So if they continue to breed, the only crocodiles left will no longer look like Cuban crocodiles, even if the DNA persists. You just won't have that morphotype anymore. I've heard that idea put out there for Neanderthals, that they just, as they were breeding with us, the young just looked more Homo sapiens, and you now just no longer had any populations that had the features of Neanderthals. And I don't know if what the status on that idea is.
Yeah, so when in the few lucky cases where we have a Homo sapiens fossil from, say, about 40,000 years ago, and it does have some Neanderthal DNA in it, we see that the amount of Neanderthal DNA decreases over time, which of course makes sense because the immediate offspring must have been about 50-50. But population-wise, it's decreasing over time, and where we have Neanderthal DNA today is mostly not in important parts of the genome. And so particularly around any of those really important genes, it has been weeded out, presumably because individuals who had Neanderthal DNA in these like absolutely important genes for development, like what if we had to rank our most important genes, whatever you want to call them, like that's not where you find the Neanderthal DNA. So it seemed like having Neanderthal DNA was not particularly helpful for Homo sapiens, and it did get weeded out over time. But yeah, it would be cool if we had the full skeleton so we could actually say, and what did those individuals look like? Did they start looking less and less Neanderthal, or did they already look not very Neanderthal from the start? Those individuals, we just kind of have fossil fragments, so I don't know what their full body looked like.
That would be very interesting to find. Is it a blending of features, or did they just end up more strongly resembling one side of the parentage? Cool. All right. Yeah, I'd heard that idea thrown around, and I didn't know if there was actually much backing to it, or if it was just something that came up as we realized how much interbreeding had happened.
So 40,000 years ago or so, Neanderthals ceased to be, and like you said, Bridget, way at the top of our discussion, sadly, there are no Neanderthals still around. But as we also have been hinting at, Neanderthals are not 100% gone from the planet. There is some Neanderthal sort of remaining within many of us. So just very briefly, on sort of a posthumous note for Neanderthals, what is the nature of that DNA? What does it mean that the three of us here in this conversation have some Neanderthal DNA with them?
Well, it hasn't been found in like particularly interesting genes. It's either in stretches of the genome that, as far as we know, doesn't do anything, or we don't know what it does. Places where it has been found in functional understood genes often relate to skin pigmentation or body hair, which is something you might expect because Neanderthals evolved at higher latitudes, so they probably had fairer skin, probably had different hair, maybe they were hairier. We don't have any total evidence for that, but you would expect in a cold climate you might evolve that feature. And so, genes related to keratin. So kind of those very, very superficial features.
Yeah.
And not too much that has been, tremendously interesting. I couldn't say like, oh, you have Neanderthal intelligence or something like that.
Right. It's not like we get our eye color or something cool and visual that we can say that's a Neanderthal trait.
And it's fun. As an aside, a lot of times how the kind of quick way to do these studies is they look at 100,000 living humans with genomes, and they find the Neanderthal DNA in them. And they've also had these people like fill out surveys of all these different traits they have and look for correlations. So it might be like there are studies that actually say like, oh, if you have this Neanderthal gene, you're more likely to smoke cigarettes. But do I think Neanderthals smoked cigarettes?
Right,
I don't know.
Right. Yeah. Neanderthals, high incidences of lung cancer, addicted to nicotine. Wouldn't expect it. But they looked. It's a shame they didn't make it to Hollywood, right? They were so cool.
Compensate for the lack of chin. Well, and those genes, what you were saying, like it doesn't seem like the genes we find it in were that there wasn't cases of hybrid vigor where we're getting some super genes from Neanderthals that just really stuck around and shaped Homo sapien genome and evolution. It's incidental genes, things that aren't majorly shaping the way we would have potentially functioned or developed.
At least the ones that stuck around.
Yeah, and
like you were saying,
mentioning the ones in some of the older genomes as well were not. You said those weren't the critical genes as well in those cases a lot of time.
Well, that's what we found so far. The one case where you might say hybrid vigor or adaptive introgression, really, like a gene acquired from different humans that was absolutely an adaptation. It's actually not with Neanderthals, it's with Denisovans, this third type of humans that were found in Asia. And some living individuals have Denisovan DNA as well. Their ancestors bred with Denisovans. And in particular, people who live on the Tibetan plateau, Tibetans, have a particular variant of this EPAS1 gene that is related to blood hemoglobin, that for decades it's been known this helps them live at high altitude without getting the horrible consequences of altitude sickness. And people have known about this interesting variant that populations in, super high on Earth have, Tibetan populations. And after they got a genome from a Denisovan fossil, they realized it's the Denisovan variant. So the ancestors of people now living on the Tibetan plateau at some point mated with Denisovans, got this gene that now allows them to live at high altitude.
Well, guess we'll have to do a Denisovan episode.
Yeah.
So if you want to come back, Bridget, for a Denisovan episode someday, maybe we'll do that. Thank you very much for coming to the podcast to talk with us about Neanderthals. This has been a really interesting discussion, and this is one of those topics that comes up on the podcast that it feels like there's at least as much that we said that we didn't say that could be said about Neanderthals. They're such a fascinating group.
Yeah, I learned a ton. This has been awesome.
Yes. Before we officially wrap everything up for the episode, there is one last thing to do, one last section, and that is our patron question. One of the benefits that our patrons can get on Patreon is the ability to submit questions for us to answer here at the end of the podcast. And I do have a question here that is sort of related to the topic of studying humans of the past. Ryan asked, imagine if all humans, modern humans, us, disappeared, and then millions of years from now, some new scientific species discovers evidence of us and our culture. Can you speculate on what erroneous conclusions they might draw about us?
Yes, about what things are left behind.
This is a really fun question. And Bridget, we are happy to have you weigh in on this as our ancient hominids person.
That is a great question. I would say two big areas they'd probably misunderstand us. The first is figuring out what our religions were, what we worshipped, and things that, our behaviors seem to prioritize, like, artifacts of capitalism, for instance, or our cars or something. They might think we worshipped as gods.
Yeah, right. Yeah.
Maybe we do, but wouldn't say it. So that's always tricky, just like the Neanderthal burials, saying, did they do this because of some sort of spiritual beliefs, or was there some other reason they were doing this?
I remember hearing the joke many years ago, the joke of future archaeologists noting that every household in this, here in North America has this shrine made of porcelain.
Yep.
In this room that maybe is there for offerings or something.
Yep. Another thing is I bet these, future creatures who do the archaeology of Homo sapiens would think we didn't know climate catastrophe was coming and didn't have the warning signs and, like the dinosaurs and we're just going about our business and, oh no, we went extinct, rather than, having all the data to say we should change our ways.
If only this ancient human species had developed the technology enough to be able to recognize that this was happening and then do something about it.
Yeah. That would be a very karmically fitting. Right. Also back like, oh, you poor unsophisticated people. No wonder you went extinct.
Right.
You weren't even paying attention to the weather.
You didn't even know. Yeah, that's a sobering thought. I have heard the note made from for people that especially modern, like today modern humans, so much of what we work with is digital.
Yes.
And none of that would survive into a geologic record, and so you'd lose so much of that information.
Well, and our architecture has also gotten more and more efficient, but less long-lasting stable. Like Stone structures are stone, so they sit there for a long time. But like wooden houses, those are not going to survive nearly as long because they're much more efficient usage of materials, but not nearly as stable materials.
Yeah.
And same with a lot of even metal structures where it's mostly empty space because we've made very efficient structures, but now there's not nearly as much mass like a pyramid, which is solid.
So we would be very confusing.
Oh yeah,
we would be very confusing to this mysterious future culture of archaeologists.
Well, I wonder about like blendings of cultures that have moved to different places in the world but maintained a lot of their practices. Would that be clear that it's like, oh, obviously they came from here, or would that be confusing as to why you see pockets of seemingly the same culture just spread out and randomly patchy around the globe?
Well, we debate that since the start of archaeology. So
yeah.
The earliest stone tools, as soon as you start to see them spread, is it independent invention, or did people actually move, or did one group copy another? So yeah, probably the same debates.
Absolutely.
Yeah. Well, there's so much more thoughts that we could share with that. Listeners, feel free to leave a comment with your own thoughts about what we would leave confusing for future archaeologists.
How many humans are fossilizing now? Have we made things not as...
Have we made it harder or easier?
Exactly.
Yeah. Ryan, thank you for that thought-provoking question. We enjoyed it. Thank you to all of our patrons who support us and allow us to do the podcast the way that we do it. Thank you, as always, to all of our listeners for listening. Every listener is part of that support and that feedback that we get that helps us keep the podcast going. Thank you to the listeners specifically who requested this episode topic and gave us the excuse to invite Bridget here to tell us all about our ancient cousins. And finally, the biggest thank you to you, Bridget, for joining us on this episode of the podcast. We really appreciate it.
Thanks for having me. It was fun.
As always, dear listeners, if you have more requests for other ancient human-related topics or any topic at all, you can submit your request to us. We now have a form. Hop on down to the episode description and it will lead you to the topic request form on our website. Other than that, by the time this episode comes out, we should be looking ahead to November, which means keep your eyes out for our spooky live stream on November 11th. That's going to be a lot of fun. And before too long, we will be putting out the form for our end of the year Q&A.
It is about that time
for people to submit their questions. Other than that, feel free to contact us in all the usual ways. Join the Discord, follow us on social media. There will be a blog post on our website after this episode with more links and images for you who want to dive deeper. And I think that's everything.
I think we're good.
We release episodes every fortnight. Stay tuned for more stuff as we go through the last handful of episodes for the year. And then before we officially play the outro music one last time, thanks so much, Bridget, for joining us. We've had a great time learning about. This is the nice thing about guest episodes, is that we just get to sit here and learn stuff, which is great.
It's learned so much, and it was so much fun. The Neanderthals are awesome.
Yes.
Yes, I'm glad to spread my pro-Neanderthal propaganda whenever I can.
Yes, this is a pro-Neanderthal podcast.
Yes, indeed.
One more thing to put in here. We have some names to thank. Extra special thanks to our top-tier patrons, Sarah May, Danielle the Bug Lover, and Robert Mart. Thank you so much for your support. We had to come in and add this into this episode outro after the fact because we recorded this before anyone had signed up for these top-tier levels.
Yeah, before we opened it up.
After we opened them up. And it did not occur to us that a bunch of people would jump at the chance to sign up for those top tiers, and then we would have missed saying their names in this episode.
Yep, so thank you.
Thank you, Sarah May, Danielle, and Robert, so much. You'll hear your names more in the future.
Bye, everybody.
Bye.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.